Welcome back to Sleep Nova. Sit back, relax, and don't forget to comment where you're watching from down below. It's amazing seeing people all around the world supporting my small channel. Now, enjoy the show. The sun rises in silence, but its presence is a chorus that has echoed through every age of life on Earth. Every morning, its gentle light spills over the horizon and washes the world in gold. In that light lies an ancient promise: warmth to nourish the living, energy to spark the green fuse of plants, and comfort to chase away the chill of night. For as long as creatures have walked under the sky, they have felt the sun's touch and known instinctively that this brilliant star is the giver of life. Yet the sun is more than a kindly nurturer. It is a colossal power, a raging sphere of fire suspended in the darkness of space. From across the cosmic void, it seems tame, a perfect golden disk that rises and sets with reliable grace. But up close, it is wild and untamable, a seething ocean of plasma and magnetic fury. It holds Earth in its grasp, guiding the dance of days and seasons. And it could, in an instant of cosmic anger, scorch our world lifeless. The same sun that gently warms our faces can also unleash deadly radiation and storms of charged particles. It is a giver of life, and it can be a destroyer of worlds. Our ancestors revered the sun as divine, calling it by many names and worshipping its life-giving light. They built great stone circles and temples aligned to its rising, celebrated when it climbed high in summer, and feared its waning in winter. In rare moments, when the sun vanished in a daytime eclipse, they watched in dread and awe as day turned to twilight, praying for the light to return. They sensed its dual nature, its generosity and its danger, even without knowing the science. We now understand that the sun is a star, one among countless others in the galaxy. But to us, it is unique. It is our star, the hearth of our solar system, the steady heartbeat of our cosmic home. It beats silently, a deep thrum of nuclear fires and magnetic pulses that we cannot hear, but that sustains us nonetheless. Every ray of sunlight is a note in that silent symphony, a connection between our small lives and the vastness of the cosmos. Consider this: the light that caresses your skin today began its journey at the core of the sun long before you were born. The warmth on your face is the end of a story that started deep in a stellar furnace. The sun bridges our brief human moment and deep cosmic time. It links the atoms in our bodies to the atoms in distant stars. In its light, we find both our origin and our destiny. We stand in the glow of a cosmic engine, often unaware that above us, a star's turbulent heart is burning and beating ceaselessly. To truly know the sun, we must journey into its very heart. Let us leave behind the blue of our sky and travel inward into the blinding brilliance, into the inner sanctum of our nearest star. What we find there is both humbling and wondrous, a story of creation and destruction, of light and darkness, of a star's life from birth to death. It is, in many ways, the story of ourselves, written in the language of light. Imagine plunging through the sun's surface and journeying toward its center. As we descend, the light intensifies and the heat becomes unimaginable. Deep inside, at the very core of the sun, we enter a realm of staggering pressure and temperature. Here in this stellar heart, hydrogen atoms are crushed together so tightly that they fuse into helium. In that act of fusion, a tiny bit of matter transforms into pure energy, an alchemy that powers the sun. This is the engine of creation hidden in the sun's core. Every second, an immense burst of energy is released, radiating outward to keep the star shining. Gravity presses inward relentlessly, trying to collapse the sun under its own weight. but the fury of nuclear fusion pushes outward, holding the star up. In this balance between gravity and fire, the sun's core burns steadily, a sphere of blazing plasma denser than solid iron and far hotter than any furnace on Earth. The core is a place of extremes beyond our experience. Its light is born in blinding abundance, yet none of that brilliance escapes directly. Only ghostly particles called neutrinos slip away unhindered, streaming out from the core and passing through the sun's layers, and even through our bodies on Earth, as though nothing were there at all. They are the silent heralds of the sun's heart, whispering of the nuclear fires within. Moving outward from the core, we enter the radiative zone, a vast internal layer where the energy from the core migrates slowly outward in the form of light. Here, photons of radiation ricochet through a dense maze of atoms. A single particle of light, born in the core's fury, may bounce countless times from one atom to another, absorbed and re-emitted in an endless random walk. The plasma in this zone is so opaque and crowded that progress for any ray of light is agonizingly slow. Ages pass as the energy inches its way outward. What we eventually perceive as sunlight on Earth has spent eons fighting its way through this hot, stifling labyrinth. In these deep regions of the sun, energy is transferred not in a simple beam, but like a traveler lost in a thick forest, zigzagging gradually toward freedom. Eventually, the character of the sun's interior changes. Further out, the stellar plasma becomes cooler and less dense, and it can no longer transport energy purely by the random diffusion of photons. At this point, a new process takes over: convection. We have entered the convective zone, the sun's outermost interior layer, where heat is carried upward by the motion of the gas itself. Picture an immense cosmic cauldron boiling slowly. Hot plasma from the layers below becomes buoyant and rises toward the surface, carrying energy with it. Upon reaching higher, cooler regions, it loses heat, becomes denser, and sinks down again to be reheated. These rolling currents form giant looping cells of plasma the size of continents, rising and falling in rhythmic surges. Through the convective zone, energy that once took millennia to crawl outward now surges toward the surface in a matter of mere weeks, riding the updrafts of this titanic, boiling motion. At last, the energy reaches the visible surface of the sun, the photosphere. This is the layer where the sun's light finally escapes into space and shines freely across the solar system. To our eyes, the photosphere is the sun's radiant face, a glowing golden disk with a sharply defined edge. Up close, it would not appear smooth at all, but finely textured and ever-changing. The surface seethes with the imprint of the convection below, a pattern of granules, like a vast mosaic of luminous cells. Each granule is the top of a convective plume, a cell of hot plasma rising from the depths. Their centers glow bright and white-hot, where fresh energy wells up, and their edges darken to a deeper amber, where cooler plasma is sinking back down. This granular pattern continually shifts and reforms, as though the sun's face is a living, boiling sea of light. Here and there, the photosphere is marred by dark blemishes, sunspots. These spots are cooler than their surroundings, and so they appear nearly black against the brilliance of the sun's face. A sunspot is born from the sun's magnetic mischief. Intense magnetic fields well up from inside the sun and suppress the hot rising gas, creating a region that is slightly less hot and thus darker. Sunspots can grow to be larger than the entire Earth and may last for days or weeks before dissipating. They are a sign that the sun's magnetism, though invisible, is ever present, knitting itself into the solar surface. We will soon see how these magnetic forces can erupt in violence, but for now, standing at the surface of the sun, we behold a roiling ocean of fire extending in all directions, a vista of constant boiling creation. Peering at the sun's face with sensitive instruments, we find that it is also vibrating subtly. The boiling convection within causes the sun to ring like a resonant bell. Its surface shivers in patterns, waves traveling across and through the sun, making the whole star gently pulse. Astronomers use these pulsations, this music of the sun, to probe its interior, much as one might learn the shape of a bell from the sound it makes. Through this solar symphony, we can discern the flowing currents deep inside, the building magnetic fields, and even hints of the sun's core, all hidden beneath the blinding glare. Rising above the photosphere, the sun's atmosphere continues outward in layers of increasing mystery. Just above the visible surface lies the chromosphere, a tenuous veil of gas that appears as a faint, pinkish glow. Here, the temperature, which had cooled at the photosphere, begins to climb once more. The chromosphere is like the sun's shimmering halo, visible clearly only when the bright photosphere is hidden during a solar eclipse. In those rare moments, it can be seen as a thin rim of ruby light encircling the moon's silhouette. Within the chromosphere, slender jets of plasma, called spicules, continually shoot upward, each one ephemeral and short-lived, lasting only minutes before falling back. The chromosphere is a restless transitional zone, a place where the fury from below meets the stillness of space above, and the solar atmosphere prepares for an abrupt and profound change. Above the chromosphere lies the sun's crown, the corona. Faint and otherworldly, the corona is a vast halo of pearly light that surrounds the sun and stretches far into space. It is breathtakingly beautiful and enigmatic, revealed to human eyes only during a total solar eclipse, or through specialized telescopes that block the sun's glare. In those brief eclipse moments, when daytime twilight descends and the moon hides the sun's brilliance, the corona appears as a pale, white aura, etched with luminous streamers and delicate filaments extending in all directions. But the corona is not merely a spectacle of light. It is a furnace in its own right, one far hotter than the sun's surface below. While the sun's photosphere is blisteringly hot, the corona above is unimaginably hotter, a puzzling reversal of what one might intuitively expect. In this outermost layer, the sun's magnetic field rules supreme, shaping the thin gases into graceful loops and arching structures. Great magnetic arches rise high above the sun, filled with incandescent plasma that traces the invisible lines of force. The corona is incredibly thin, its particles so sparse that if you were standing in it, shielded somehow from the heat, you might not even notice the few atoms brushing by. And yet, despite its tenuousness, the corona possesses immense energy and reaches temperatures of such magnitude that scientific instruments must strain to record them. Why does the corona burn so fiercely? It remains one of the sun's lingering mysteries. Perhaps the sun's tangled magnetic fields thrash and snap, heating the gas in a myriad of tiny explosions, or waves of energy ripple outward from the sun's surface, dumping heat into the corona. Whatever the cause, the sun's crown glows with an ethereal fire that science is still striving to fully understand, a reminder that even our well-known star holds secrets at its heights. At the edge of the corona, the sun begins to fade into the darkness of space. There is no sharp boundary where the star ends. Its atmosphere simply thins into the void. Here, the corona gives birth to the solar wind, a ceaseless stream of charged particles, electrons and protons, that flows outward in all directions. The sun, in effect, is always breathing out. Its breath is the solar wind, and it carries a piece of the sun's essence out to the farthest planets and beyond. The gravity that so overwhelmingly confines the core cannot hold these fast, lightweight particles of the corona. They race outward along open magnetic lines, escaping the sun's grip. The solar wind is, in a sense, the sun's extended atmosphere flowing freely into space, filling the solar system like an invisible, ever-expanding bubble. We have now traveled from the sun's core, where matter becomes energy, to the wispy fringes of its corona, where the star dissolves into the broader cosmos. In this journey, we have witnessed the anatomy of a star, its layered realms, each with its own wonders. We have seen the ferocious furnace at its center, the slow upward struggle of light, the boiling convection that brings energy to the surface, the radiant face shining into space, and the crown of fire that reaches beyond the sun itself. Yet the sun is far from a static ball of gas. It is dynamic and alive, its surfaces and atmosphere writhing with magnetic fields and sudden eruptions. To truly understand our star, we must explore these invisible forces that bind and sometimes unravel the sun's material. We must watch as the sun's calm radiance is punctuated by storms, blazing flares, erupting prominences, and billowing clouds of plasma that can span millions of miles. It is time to examine the sun's magnetic heart and the space weather it breathes into the solar system. Beneath the sun's bright face lies an unseen web of forces that drives its most dramatic behavior. The sun is a giant magnetic dynamo. As it spins on its axis and its plasma churns, it generates magnetic fields that thread through its interior and arch out into space. Imagine lines of unseen force looping out from the sun's depths, arcing high above the surface and diving back down. These magnetic field lines become twisted and tangled by the sun's constant turning and boiling. Where they burst through the surface, they drag up or suppress hot plasma, creating the dark sunspots we see freckling the photosphere. Every feature we observe on the sun, its spots, its flares, its glowing coronal loops, is shaped by magnetism. Without the magnetic field's influence, the sun would be a far more monotonous star. Instead, magnetism makes it a living, breathing, and sometimes tempestuous entity. Sunspots are the most visible signs of the sun's magnetic moods. They tend to appear in groups, often as pairs linked by a great looping magnetic field. One spot will have a north magnetic polarity, the other a south, like opposite poles of a bar magnet. The arc of magnetism connecting them traps cooler plasma in its grip, outlining structures we sometimes see as prominences, towering loops of glowing gas that stand above the sun's surface. Sunspots grow and shrink as the magnetic fields beneath them strengthen or decay. Over days or weeks, a complex sunspot group may evolve. An enormous energy builds up in its tangled magnetic knots. There is a rhythm to these appearances. Roughly every decade or so, the sun swings from a time of few sunspots to a time of many, and back again. At the peak of this cycle, dozens of spots can dance on the sun's face. At the low point, the sun's visage is often clear and quiet. Each cycle, the sun's magnetic poles even flip. North becomes south, and south becomes north, as part of this regular heartbeat of our star. Our sun, like a living thing, has its seasons of storm and calm. When the stress in twisted magnetic field lines becomes too great, they can suddenly snap into a new shape, much like a tensed rope that finally breaks free. In that instant, the energy that was bottled up in the field is explosively released. This is a solar flare. On the sun's surface, a flare is a blinding flash of brightness, a sudden blaze of radiation across the spectrum. It is as if a patch of the sun's surface has detonated with the power of countless nuclear bombs. In minutes, a flare unleashes a torrent of X-rays and charged particles into space. If the Earth lies in its path, these emissions race toward us at light speed, arriving just minutes after the flare erupts. Our planet's upper atmosphere suddenly swells with energy. Radio communications can crackle and fade as the ionosphere, the atmosphere's charged upper layer, is pummeled by the onslaught, and astronauts in orbit might hastily seek shelter from a burst of radiation that moments before was not even known to exist. Flares are often accompanied by an even more massive eruption, the coronal mass ejection, or CME. Where a flare is a flash of light and high-speed particles, a CME is a giant cloud of solar plasma hurled out from the sun. When a particularly complex magnetic loop in the corona destabilizes, it can fling away a chunk of the sun's outer atmosphere entirely. Imagine a colossal bubble of electrified gas, more massive than all of Earth's oceans combined, suddenly launched into space and expanding as it races outward. A coronal mass ejection can contain an astonishing amount of matter and energy, an immense, billowing stormfront in the emptiness of space. If one of these solar tsunamis is aimed toward Earth, we will know it soon enough. Within a day or two of the eruption, the wave of solar particles reaches our planet. Earth's magnetic field recoils and reverberates from the impact, like a bell struck by a hammer. We call this disturbance a geomagnetic storm. When a geomagnetic storm engulfs Earth, the results can be both beautiful and dangerous. Under the night skies at high latitudes, ghostly lights burst forth. Auroras, the northern and southern lights. Normally, auroras are confined to the polar regions, tracing the shape of Earth's magnetic field as it directs the sun's particles toward the poles. But during a strong solar storm, auroras can be seen much farther from their usual homes, painting the skies in eerie greens, purples, and reds over a vast swath of the world. Imagine waking in the tropics to find the night sky alive with rippling curtains of light. Such an astonishing sight has indeed occurred when the sun lets loose one of its great storms. In ages past, people who witnessed auroras far from the poles were often terrified. They saw in them dragons or celestial armies, believing the heavens were aflame with omens. To ancient peoples, these luminous dances in the sky must have been both wondrous and terrifying. Even today, knowing their true cause, one cannot watch the aurora's shimmering display without a feeling of reverence for the forces at play. Yet along with this beauty comes disruption. The same geomagnetic tempest that sets the skies aglow can wreak havoc on our modern technology. The barrage of charged particles and the distortion of Earth's magnetic field can induce surges of electric current in long conductors here on the ground. In our age of wires and wireless signals, a strong solar outburst can interfere with radio transmissions, scramble GPS navigation, damage satellite electronics, and even overload power grids, plunging cities into darkness. Over a century ago, a monumental solar storm made telegraph lines spark and catch fire. Telegraph operators found they could disconnect their batteries and still send messages. So powerful were the electrical currents coursing through the wires. If a storm of that magnitude struck today, satellites might be knocked offline, and extensive blackouts could occur. For all our technological might, we remain passengers in the sun's domain, subject to its occasional fits of violence. This turbulent interplay of solar magnetism and its effects on Earth and the planets is what we call space weather. Like weather in Earth's atmosphere, it has calm days and tempestuous days. The sun's magnetic field is ever shifting, and as it does, it breathes out gusts and squalls into the solar system. Most of the time, the solar wind blowing past Earth is a gentle breeze, and our planet's magnetic field shrugs it off with little fanfare. But when the sun erupts, the space around Earth becomes a stormy sea. A surge of charged particles and magnetic disturbances crashes against our planet's defenses, and near-Earth space itself reacts in kind. Auroras lighting up, satellites feeling the shock, currents coursing through the ground below, where all seems quiet. Fortunately, Earth has a sturdy shield. Our planet's magnetic field envelops us, carving out a protective bubble that the solar wind must flow around. This magnetosphere diverts most of the charged solar particles, allowing only a portion to funnel down toward the poles. In the clash of sun and Earth, the auroras are the glowing traces of our magnetic shield intercepting the solar storm, a testament to the protection it offers. Planets without a significant magnetic field, like Mars, have no such guard. Over eons, the sun's relentless particles stripped away much of Mars's atmosphere, leaving it a cold, arid world. In that fate, we see mirrored the dual nature of our sun, the gentle provider that sustained life on Earth, and the relentless force that can erode a planet's very sky. It nourished Earth with light and warmth, while its winds slowly wore Mars down. Magnetism is the hidden architect of the sun's behavior, from the steady cycle of sunspots to the wild drama of flares and auroras. Through it all, the sun continues to shine steadily in our sky, a reassuring beacon of day. But we have learned that beneath that steadiness is a flickering heart of magnetic energy. The sun's calm and its storms are two sides of the same coin, both born from the same stellar heartbeat. As humanity extends its reach into space and relies ever more on technology, studying and forecasting this space, weather becomes increasingly important. We now watch the sun with eyes open, tracing its spots and flares, listening for the whispers of its solar wind. We have even sent spacecraft to touch the sun's fringes, sampling its corona and feeling its magnetic embrace, all to better understand our star's moods. In the midst of these stellar tempests, it is easy to lose sight of the sun's most gentle and steadfast gift, the sunlight itself. Every day, countless photons leave the sun and stream across space, and some of those reach our world to illuminate the sky. Consider for a moment a single particle of light, a photon, born in the sun's core. It began as pure energy released by a fusion reaction in that dense, searing heart. For untold years, it fought its way through the sun's interior, scattering and dancing through the radiative maze, slowly migrating to the surface. At last, it broke free from the photosphere, joining the radiant tide of sunlight that floods out into the darkness. In that instant, it set out across the cosmic gulf at the ultimate speed, racing through the vacuum toward our small planet. After a brief voyage through the abyss of space, the photon pierces Earth's upper atmosphere. Perhaps it is dawn, and this tiny messenger of the day slips through a clear sky to reach a waiting leaf on a tree. The photon is absorbed, its energy triggering the chemistry of life, photosynthesis, helping a green leaf turn carbon dioxide and water into sugar. In that moment, a bit of the sun's energy, carried across the cold void by a single photon, becomes part of a living plant. Another photon falls upon a human face and is absorbed in the warm skin of someone standing under the morning sun. Nerves register the gentle heat. The mind welcomes the comfort. That warmth is a direct touch from our star, a tangible link between our flesh and the nuclear fires at the sun's heart. Every ray of daylight that we see, every soft beam reflected by the moon at night, began in the sun's core long ago. The sunshine that makes the petals of a flower glow, that draws a child's laughter on a bright afternoon, that dances on waves at dusk. All of it is energy forged in a star and sent outward as a gift across the emptiness. It is literally starlight. The light sustains the winds and rains of Earth's weather, drives the engines of life, and paints our world in color each sunrise and sunset. From the sun's perspective, these photons are a way it reaches into the darkness, touching worlds with its essence. From our perspective, they are life and time itself. Every meal we eat is sunlight captured by plants. Every sight we behold is enabled by the sun's illumination. Thus, the sunlight we feel on our skin carries an ancient story. It is the end of a journey that began in the heart of a star and a bridge between our everyday lives and cosmic processes. In that golden glow, the tumult of the sun's interior and the fury of its storms are gentled into a nurturing radiance that gives life rather than takes it. We are, in every sense, bathing in the light of a star. To stand in the sunshine is to be touched by the cosmos, to be warmed by a process that has been ongoing for eons. The next time you see dust motes dancing in a sunbeam or feel the sun's warmth on your face, remember that you are feeling the afterglow of a journey that spanned the depths of space and countless years, a journey from the core of a star to the core of your being. Beyond the orbit of Earth, the sun's influence continues in a quieter but no less significant form. The solar wind that billows out from the corona fills the solar system with a tenuous, invisible presence. Space is not truly empty. It is filled with the sun's breath. This stream of charged particles flows outward past all the planets, carrying with it a stretched-out imprint of the sun's magnetic field. It's as if the sun, through its wind, reaches out to touch each world in its orbit, linking them in a web of invisible threads. As the solar wind encounters each planet, the effects depend on whether the planet is protected by its own magnetic field or left exposed. We've seen how Earth's magnetic bubble deflects the wind, diverting the charged particles around us. Jupiter and the other giant planets have formidable magnetic fields that carve out even larger sanctuaries in the solar wind. When the solar wind presses against these magnetic bubbles, it sparks auroras at their poles too. Jupiter's polar skies glow with curtains of light far more intense than Earth's, and even Saturn wears ethereal rings of auroral light. On worlds like Mercury or our Moon, which have little or no magnetic shielding, the solar wind slams directly into the surface. It can embed particles in the soil and slowly sputter away atoms into space. Mars, with only patchy magnetic fields and a thin atmosphere, has its skies occasionally set aglow by diffuse auroras, a reminder that even without a strong magnetosphere, the solar wind still makes its presence known. Perhaps the most visually stunning evidence of the solar wind's reach is found in comets. When a comet from the frigid outer reaches of the solar system ventures close to the sun, it sprouts a luminous tail that always points away from the sun. This is because the solar wind, along with the gentle pressure of sunlight, is pushing material off the comet's nucleus and sweeping it into a tail that streams far into space. Every comet's tail is essentially a windsock, revealing the direction of the sun's breeze. In ancient times, people saw those mysterious comets with their glowing tails stretching across the sky, and perhaps sensed that the sun and the comet were interacting. Now we know it is the breath of the sun, gusting through space, that draws those ephemeral streaks. The solar wind is not a steady, featureless breeze. It has structure and gustiness. Fast streams of solar wind can overtake slower ones, creating turbulent regions out in the depths of space. Magnetic clouds and shock waves from solar eruptions course through the wind, eventually overtaking planets or other spacecraft that lie in their path. The wind also carries the sun's magnetic polarity outward. At times, Earth finds itself connected to the sun by magnetic field lines stretching across interplanetary space, allowing energetic particles from solar flares to spiral directly toward us. In this way, the solar wind is the medium that transmits the sun's influence throughout its domain, like a great cosmic ocean in which the planets sail. As our solar system journeys around the center of the Milky Way, it carries this protective bubble along. The sun, like a bee in a giant swarm, orbits the galactic core among billions of other stars. One lap around the galaxy takes an unimaginably long time. In the sun's long life so far, it has only managed a few dozen such circuits. On this grand voyage, our star drifts through changing cosmic neighborhoods. Sometimes the space around it is relatively empty. At other times it might encounter wisps of nebulae or the lingering echoes of ancient supernovae. These encounters can subtly influence the boundary of our heliosphere, perhaps even nudge comets from the distant cloud at the fringes of our solar system. We ride along on this stellar odyssey, a family of planets wrapped in the sun's embrace, cruising through the galaxy's spiral arms. It is a humbling thought that our entire existence, every life, every story told under the sun, has been carried on this great galactic journey, and it will continue long after we are gone, the sun forging ahead through the dark with its tiny companions in tow. Eventually, at some immense distance from the sun, the solar wind begins to meet resistance. The sparse gas that drifts between the stars pushes back against the sun's advancing wind. The solar wind slows, compresses, and finally, at a certain boundary, it can push no further. The continuous expansion of the sun's atmosphere is halted by the presence of the wider galaxy. This boundary marks the outer edge of the sun's influence, the frontier of our star's dominion. Here, the solar wind's long journey ends, merging into the interstellar medium. This invisible border defines a vast bubble around the sun, known as the heliosphere, a cocoon of solar particles and magnetic fields that envelops all the planets. To step outside that bubble is to enter truly interstellar space. For decades, the solar wind was only a theory, an idea to explain why comet tails always point away from the sun. It wasn't until humanity ventured into space with probes that we felt this wind firsthand. Our spacecraft have measured its particles and tasted its composition. Finally, after decades of journeying, a tiny spacecraft built by human hands passed through the boundary of the heliosphere and sailed into interstellar space, becoming the first emissary from Earth to enter the realm between the stars. It confirmed the existence of that distant frontier and carried with it a golden greeting from our world as it moved under the dim light of a sun now far behind. The sun's breath, it turns out, has a limit. Within that limit, within that bubble, the sun is Lord and life-giver. Every world we have ever known lies inside this protective sheath blown by our star. Now, standing at the edge of the heliosphere, we gaze outward and backward to the realm of the galaxy beyond, and backward toward the sun at the center of its bubble. We can appreciate the true scale of our star's influence. The sun is not just a disk in our sky. It commands a vast region of space, sculpting it with light and wind. It has forged a safe haven in the galactic sea, a place where its family of planets resides. To understand the sun fully, we must also understand how stars like it are born and how they die. For our sun is one among billions, each with its own story of origin and fate. Our journey now moves beyond our solar system, beyond the present moment of our sun's life, to the story of how such stars come into being and how they transform over time. Stars are born in darkness, far from the bright bustle of any galactic core, in the quiet spiral arms of galaxies like our Milky Way. Vast clouds of gas and dust drift in cold obscurity. These are the stellar nurseries, enormous nebulae stretching across light years of space, rich in hydrogen and sprinkled with heavier elements forged in ancient supernovae. Within these great clouds, gravity works patiently and silently. A slight densification, perhaps triggered by the shockwave of a distant exploding star or the brushing encounter of two clouds, begins to draw matter toward its center. As the gas compresses, it heats up and starts to glow faintly. What was once invisible in the darkness becomes a warm ember hidden inside a cocoon of dust. This is the birth of a star, or rather, the first whisper of a star yet to be. As the cloud fragment collapses under its own weight, it often breaks into smaller pieces, each destined to form a star, or even a small cluster of stars. In each fragment, matter spirals inward, and as it falls, it begins to spin faster, like a twirling ice skater pulling in her arms. A flattened disk of gas and dust forms around the growing central mass, whirling like a carousel. At the center of each collapsing fragment, a protostar, a baby star, is taking shape. It is not yet a true star, for it has not begun nuclear fusion, but it shines with the heat of its gravitational contraction. We can imagine it as a glowing orb buried deep within a dusty womb. If we could pull back the veil of dust and look inside, we would see a scene both serene and violent. The protostar's surface roiling with convection, jets of gas erupting from its poles and piercing out into space, and the surrounding disk feeding material steadily onto the growing stellar infant. In these concealed cradles, many stars are often born together, Siblings in a stellar brood. Some are destined to be massive and brilliant, others small and faint. For a brief time, the protostar continues to gather mass. The infalling gas rains down mostly onto the disk, which then funnels onto the star. The star grows, and the pressure and temperature at its center climb ever higher. When the core temperature at last soars to the threshold, where hydrogen atoms begin to fuse into helium, a profound transformation occurs. The protostar becomes a star. It is as if a switch is flipped in its core. The darkness inside ignites into light. The star begins to generate its own energy by the same nuclear process that powers our sun, and a new sun bursts into existence in that once dark place. With that first ignition of fusion, a stellar wind, much like the solar wind of our sun, often springs from the newborn star, and intense light from the hot young star pours into the surrounding space. These forces blow away the remaining shreds of the natal cloud, dispersing the cocoon that once hid the star. If the star is massive enough, its fierce radiation may carve fantastic shapes in the parent nebula, creating glowing cavities and pillars of dust that resist the onslaught for a time. Before long, what was once an opaque dark cloud becomes a cluster of shining new stars, its birth cloud eroded to wisps around them. The siblings now bask in each other's light as they drift together, loosely bound by gravity. Our own sun was likely born in such a cluster of stars. It may have had many siblings forming alongside it in a long-vanished nebula, all of them cocooned together and then emerging into the galaxy's light. In that stellar nursery, the sun's siblings would have shone nearby, sharing a common region of space for a time. But over the ages, the cluster dispersed. Each star, including our sun, went its own way, moving through different orbits around the Milky Way. Today, the sun's sisters and brothers are scattered, indistinguishable from the other stars of the galaxy, though astronomers scanning the sky have identified a few stars with chemical fingerprints so similar to the sun's that they might be long-lost solar siblings. In the collapse of a nebula and the birth of a star, we see nature's cycle of creation at work. The gas and dust that form new stars carry the ashes of previous generations, the carbon that will someday course through the veins of living creatures, the oxygen that will fill their lungs, the silicon that will form rocky worlds. All these atoms were fused in stars that lived and died before our sun was born, then mixed into the clouds from which new stars arise. Each generation of stars enriches the galaxy further, seeding the raw material for planets and life. Thus, when a new star like our sun ignites, it carries within it the legacy of cosmic ancestry. Around many newborn stars, the leftover gas and dust in the disk coalesce into smaller clumps, giving birth to planets, moons, comets, and asteroids, the makings of a new solar system accompanying the new sun. From afar, a stellar nursery like the Orion Nebula offers us a glimpse of this wondrous process. Through telescopes, we see stellar embryos still swaddled in dust, others breaking free and burning blue-white with youthful energy. We see great columns of dark gas, cosmic pillars, being eroded by the radiation of hot young stars hidden within them. In that radiant chaos, worlds are being formed, and light that will shine for billions of years is first kindled. Star birth is at once delicate and cataclysmic. Delicate in the slow, inexorable gathering of a star's first light, and cataclysmic in the way a newborn star's brilliance can rip apart the very cloud that gave it life. From these nurseries emerge all stars, whether destined to be mighty blue giants or dim red dwarfs. The process is the same, guided by the pull of gravity and the laws of physics that govern heat, pressure, and fusion. We have journeyed from our sun's neighborhood out into the broader galaxy to witness the origin of stars. Now, having seen how stars take their first breath, we can explore the grand tapestry of stellar variety. the many kinds of stars that fill the cosmos, from the smallest embers to the most luminous beacons. The stars that populate the universe are as diverse as the creatures in a great ocean. They come in different sizes, colors, and brightnesses, each type with its own character. Astronomers classify stars by their temperature and luminosity, which often correlates with color. Just as iron glowing in a blacksmith's forge changes from dull red to orange to white hot as it gets hotter, a star's color tells us its heat. The coolest stars are deep red, smoldering with a subdued cherry glow. Hotter stars shine in yellow and white hues. The very hottest stars blaze with blue-white brilliance, their surfaces incredibly hot. The smallest true stars in the cosmos are the red dwarfs. These diminutive stars contain only a small fraction of the sun's mass and glow feebly, often with a light so faint that none are visible to the naked eye from Earth, despite being the most numerous stars in the galaxy. A red dwarf is usually much smaller and cooler than our sun, giving off a ruddy light. But what they lack in brightness, they make up in longevity and ubiquity. The vast majority of stars in the Milky Way are thought to be red dwarfs, quietly burning their fuel at a glacial pace. A red dwarf may live for an almost eternal span of time before it runs out of fuel. In these diminutive furnaces, the flame of nuclear fusion is weak but extraordinarily steady. Some of the smallest red dwarfs can continue to shine for longer than the current age of the universe. On the other end of the stellar spectrum are the blue giants and supergiants. These stars are born with many times the mass of the sun. They are extremely hot and brilliant, shining with a fierce blue-white light that can be seen across great distances. A blue giant star pours out an enormous amount of energy, consuming its hydrogen fuel at a prodigious rate. Because of this, its life is intense and fleeting. It will exhaust its core fuel in a cosmic eye blink, a mere moment compared to the tranquil longevity of a star like our sun. Some of these massive stars do not stay blue-white for their whole lives. As they age, they swell and cool, turning into red supergiants that can be truly colossal in size, their bloated atmospheres expanding outward to stupendous dimensions. Imagine a star so large that, were it placed where our sun is, it would extend beyond the orbit of Earth and well into the realm of Mars. These red supergiants glow with a cooler, reddish light, but they are tremendously luminous due to their sheer size. They are rare and splendid beacons in galaxies, heralds of impending cosmic change, for they live fast and die spectacularly. Between these extremes lies a rich variety of stars. There are orange dwarfs, slightly smaller and cooler than the sun. There are white stars, somewhat hotter and more massive than the sun. And there are stars like our own, yellow-white and medium-sized, often called main sequence stars or dwarf stars by astronomers. Our sun, in fact, is considered a dwarf star in this sense, not because it is especially small, it is larger and more massive than most stars, but because it is in the prime of its life, steadily fusing hydrogen in its core. It hasn't yet bloomed into a giant. In terms of mass and brightness, the sun is fairly average, but because the faint red dwarfs are so inconspicuous to our eyes, most of the individual stars that dazzle us in the night sky are actually more luminous than our sun. Many of the bright stars we see at night are larger, hotter, or more energetic than the sun, which is why they stand out from afar. Meanwhile, countless dim red stars nearer to us go unnoticed without a telescope. Stellar classification also includes exotic categories. There are the supergiants we mentioned, both blue and red, which are essentially stars on steroids, far larger and more luminous than ordinary stars. And there are stars at the very brink of not being stars at all, the brown dwarfs, sometimes nicknamed failed stars. These objects form in the manner of stars but do not accumulate enough mass to ignite sustained hydrogen fusion in their cores. A brown dwarf glows faintly with leftover heat from its formation, and perhaps with brief flashes of fusion of heavier forms of hydrogen, but it gradually cools and fades, acting more like a giant planet than a true star. Brown dwarfs fill the gap between the largest planets and the smallest red dwarfs, and they add to the menagerie of objects in the galaxy. Nature produces stars in a continuum of masses and sizes, from tiny red embers that burn for practically eternity to stellar titans that blaze with incredible intensity and then perish in the blink of an eye. Each type of star has its own destiny. A star's mass, set at birth, is the key that unlocks the rest of its life story. With a high mass comes a glorious but short-lived existence as a giant, likely ending in a dramatic explosion. With a low mass comes a long, steady burn and a quiet retirement. Having surveyed the variety of stars, the small, the medium, the great, we can now follow one typical star, perhaps not unlike our sun, through the stages of its life, from its youthful radiance to its final farewell. Let us trace the fate of a star much like our sun, now that it has burned in the heavens for eons. For a long time, such a star shines steadily, fusing hydrogen into helium in its core and bathing any nearby worlds in stable light. But the fuel at its center is finite. Eventually, after many billions of years of shining, the hydrogen in the core dwindles. The balance that sustained the star for so long begins to tip. With less fusion to support it, the core of the star starts to contract under its own gravity. As it contracts, it heats up, much as a bicycle pump grows warm when you compress the air inside. This extra heat flows into the shell of hydrogen that surrounds the inert core, a shell that still has hydrogen left to burn. And then something dramatic happens. Hydrogen in this outer shell, now at extreme temperatures thanks to the contracting core beneath, ignites in fusion. The sudden onset of shell burning causes the star's outer layers to push outward. The star swells enormously in size, turning into what we call a red giant. Its surface cools as it expands, shifting from yellow-white to orange-red. But the star's interior becomes hotter than ever, and its luminosity soars due to its sheer size. Our once modest sun-like star becomes a bloated colossus. In this red giant phase, the star's radius can grow far larger than it was in its youth. If our sun were to undergo this transformation, it would likely engulf Mercury and Venus, and perhaps even Earth, turning those worlds into charred cinders swallowed by the expanding stellar fire. The sky of any surviving outer planets would be dominated by the star's enormous disk, a brilliant coppery orb covering a huge swath of the heavens. Deep inside the red giant, the core continues to shrink and heat, as it is now made mostly of helium ash, the byproduct of those long ages of hydrogen fusion. When the core grows hot enough, a new kind of fusion begins. Helium atoms start fusing together to form carbon and some oxygen. Our star, which was facing death, finds a second wind. The onset of helium fusion in the core, often beginning in a sudden burst for a sun-like star, something astronomers poetically call the helium flash, stabilizes the star for a time. The core expands a little and cools, and the star's bloated outer layers contract somewhat from their extreme size. The star settles into a new equilibrium, a helium-burning giant. In this phase, the star's color might become a bit more yellowish as it slightly shrinks, and its surface temperature rises again, and it burns steadily once more, though its remaining lifetime is now comparatively brief. But helium, too, is a finite fuel. In time, the core's helium is exhausted, leaving an inert mass of carbon and oxygen, the carbon and oxygen that were created by the helium fusion. For a star like our Sun, no further fusion is possible in the core. The temperatures required to ignite carbon are beyond its reach. With fusion ceasing again in the center, the core of the star, now a dense ball of carbon and oxygen, contracts yet further. Meanwhile,
Helium fusion may continue in a shell around the core, with hydrogen fusion still going in a shell above that for a while. This causes the star to swell once more, even larger than before. The giant star becomes highly unstable in this final stretch of its life. It pulsates, growing and shrinking, trying to find balance, but never quite succeeding. Each expansion and contraction shakes loose some of the star's outer layers. Gentle at first, these pulsations turn into violent throes that throw vast clouds of the star's outer atmosphere into space. The star is literally coughing away its own substance, shedding its mass like tears into the void. Eventually, the entire outer envelope of the star is cast off, blown away into space as a gorgeous gossamer shell of gas. For a brief time, that expanding shell is illuminated by the hot, exposed core at the center, and it shines as a glowing, multicolored cloud known as a planetary nebula. To an observer afar, it is a sight of eerie beauty. A round or ring-shaped mist, glowing where once there was a star, often with intricate patterns like delicate rings or hourglass forms. This is the dying breath of a star like the sun, a final gesture of beauty as its outer layers, now free in space, fluoresce in the stellar twilight. What remains of the star itself is the central core, now revealed, a ball of carbon and oxygen about the size of Earth, tremendously hot but no longer sustained by fusion. This is a white dwarf, the ember of a star's heart. It glows white-blue with residual heat, initially extremely hot, though its small size means its total light output is relatively modest. A white dwarf is one of the strangest forms of matter in the universe. It is supported not by heat or ongoing fusion, but by the quantum pressure of electrons, a fundamental resistance of matter to further compression. Its density defies imagination, the mass of a sun compressed into a sphere the size of a planet. A spoonful of white dwarf material would outweigh a mountain. In this exotic, degenerate state, the stellar core will sit and slowly cool for time spans beyond human comprehension, fading from white to yellow to red, and eventually toward blackness. Thus ends the life of a sun-like star, not with a bang, but with a serene farewell glow. The mighty red giant's cast-off shroud becomes part of the galaxy, seeding space once more with elements like carbon and oxygen that will one day find their way into new nebulae, new stars, new planets, and perhaps new living beings. The white dwarf that remains is like a stellar tombstone, an extremely dense crystal of carbon and oxygen. Some have likened a white dwarf to a cosmic diamond, marking where a shining sun once lived. Over eons, it will cool further and dim, eventually becoming a black dwarf, a hypothetical cold dark sphere, the final quiet cinder of a once radiant star. The universe, however, is not yet old enough for any white dwarfs to have cooled completely to black. That final stage lies in the far future, far beyond the present age of the cosmos. Our sun will one day follow this very path. It is the destiny of all stars in its weight class. But not all stars share the same fate. The most massive stars, those bright blue giants we discussed, live dramatically different lives and meet far more violent ends. Before we return to the personal tale of our own sun's future, let us first briefly touch on the spectacular final act of those heavier suns, a fate that leaves behind some of the most enigmatic objects in the cosmos. While a star like the sun ends its life in relative peace, the same cannot be said for the giants. The most massive stars go out with staggering violence. After burning through hydrogen and helium in a cosmic rush, a high-mass star, far more massive than our sun, doesn't stop at carbon and oxygen. Its core, under tremendous gravity, continues fusing heavier and heavier elements in layers, like the layers of an onion. Carbon fuses into neon, neon into oxygen, oxygen into silicon, each stage burning faster and yielding less energy than the last. Finally, the core is transmuted into iron, the ash of nuclear fusion, an element that cannot release energy by fusing further. When enough iron accumulates in the core, the star faces an irreversible crisis. With no new energy to support it, the iron core collapses in on itself in a fraction of a second. The core implodes, and densities reach such extremes that atoms are crushed. Protons and electrons melt into neutrons. The core, which was once perhaps the size of Earth or smaller, shrinks to a sphere only a few miles across in an instant. In that moment of collapse, a phenomenal amount of gravitational energy is released. The infalling outer layers of the star hit this super-dense core and rebound outward in a titanic explosion, a supernova. The star's death throes are so violent that for a brief time, the exploding star can outshine all the billions of other stars in its galaxy combined. The supernova blasts the star's outer layers into space at incredible speeds, and shockwaves race through the expanding debris. Temperatures in the explosion briefly soar so high that elements heavier than iron are forged in the fiery crucible. Gold, silver, uranium, and many others are synthesized in those final furious seconds. These newly minted atoms are hurled into the cosmos to mingle with the gas and dust that will eventually form new stars and planets. What remains at the center of this cataclysm is the collapsed core. If the star was only moderately massive, on the lower end of the massive star range, the core's collapse is halted by the pressure of densely packed neutrons. Matter squeezed so tightly that the neutrons resist any further compression. The core becomes a neutron star, an object of incredible density and exotic nature. A neutron star packs more mass than our Sun into a sphere only a few tens of miles wide. It is essentially a giant atomic nucleus, a ball of neutrons left behind by the supernova. A thimbleful of neutron star material would outweigh a mountain. Neutron stars often spin rapidly. The parent star's rotation speeds up dramatically as it collapses, like a pirouetting skater pulling in her arms, and they may possess intense magnetic fields. Some neutron stars sweep beams of radiation from their magnetic poles as they spin, like lighthouses in the cosmos. These are observed as pulsars, blinking radio or X-ray beacons, marking the location of a neutron star across the galaxy. For the most massive of massive stars, even neutron degeneracy pressure cannot hold the core up. If the collapsed core is above a certain critical mass, nothing known can stop its collapse. It continues to shrink until it essentially vanishes from view, forming a black hole. In that case, the stellar remnant has crushed itself into a point of virtually infinite density, enveloped by a region of space from which nothing can escape. Not even light can climb out of the warped space around the collapsed core, hence the name black hole. What was once the heart of a star becomes a kind of cosmic abyss, a pit in the fabric of the universe. A black hole can be thought of as the star's ultimate tombstone, carrying its mass hidden within a distortion of space-time. We infer its presence only by ghostly tracers, the desperate whirl of gas and dust spiraling into invisibility, flaring in X-rays as it vanishes, or the subtle quivering of space-time itself when the black hole is jarred by the fall of something massive. When a supernova finally fades, it leaves behind these strange remnants, a neutron star or a black hole, and an expanding cloud of gas and dust that was once the star's outer layers. In time, that cloud will cool and disperse into the interstellar medium. The elements cast into space will blend with other matter and eventually become part of new stars, new planets, and perhaps new life. Massive stars, though few in number compared to red dwarfs, are the great alchemists and fireworks of the universe. In dying, they sow the heavy elements across the galaxy, the very elements that make rocky planets and organic beings possible. Every atom of calcium in your bones, of iron in your blood, was forged in the belly of a star that ended in such a blaze. The cosmic ashes of supernovae fertilize the galaxies, ensuring that each new generation of stars is born with a richer array of ingredients for planets and for life. We have traced the lives of stars from gentle birth in nebulae to either a quiet sunset as a white dwarf or a cataclysmic finale as a neutron star or black hole. But our exploration of suns would be incomplete without considering that stars rarely live in isolation. Most have companions or families of their own, multiple star systems bound in gravitational dances or retinues of planets that circle around them. Our sun itself has a family, the planets, including Earth, and smaller bodies that formed from the disk of dust left over from the sun's birth. And many stars form in pairs or trios, locked in orbits around each other. To truly understand the nature of suns, we must also look at these relationships, the celestial communities that stars form, and the diverse planetary systems that have arisen around distant suns. Each star in the night sky is a sun in its own right, and many are far from solitary. In fact, most stars are born as multiples, two or more suns bound together by gravity, orbiting a common center. Imagine a binary star system, two suns locked in an elegant dance, circling each other over years or centuries. From a distance, they might appear as a single point of light, but up close, each partner star swings through space in response to the other's pull. Some binaries are widely separated, each star carrying its own retinue of planets. Others whirl so close that they can trade gas, or even, in extreme cases, merge into one. In a triple or quadruple system, the dance grows even more complex, with stars tracing intricate paths around their mutual center of mass. The universe is a grand stage, with every stellar configuration you can imagine. There are suns that eclipse one another from our viewpoint, causing their combined light to rhythmically dim and brighten, cosmic beacons signaling their orbital waltz. There are stars so close that they share a common envelope of gas, two stellar hearts wrapped in one glowing shroud. And there are systems where small companion stars orbit giant ones in distant loops, like tiny sparks flitting around a great flame. Around many of these suns, planets coalesce and circle, for planet-making is a natural companion to star-making. When a star is born from a spinning disk of dust and gas, the leftover material often forms worlds. Our own solar system is one example, a handful of major planets and a retinue of smaller bodies. And we have learned that planets are astonishingly common. We now know that planets accompany stars throughout the galaxy. Astronomers have discovered innumerable exoplanets orbiting distant suns, and they suspect that for every star we see, there are likely worlds in attendance. There are planets that cling close to their stars, scorched and locked by gravity, so that one hemisphere endures endless day while the other is in perpetual night. There are planets at just the right distances from their suns, the so-called habitable zones, where conditions might allow liquid water and the chemistry of life. Some planets orbit twin suns, experiencing double sunrises and double sunsets, their skies graced by two stellar disks. Imagine standing on such a world, with two faint shadows dancing on the ground, or on a world under a dim red dwarf sun, where the daylight is a brooding ember, and the stars' frequent flares paint the sky with sudden ruddy hues. Each planetary system is a story of creation, just as every star's life is a story. Some stars have giant guardian planets that shield inner worlds from comet bombardments, as Jupiter helps shield Earth. Others have planets in wild, elongated orbits, leading to chaotic swings of climate. Some massive stars might not host long-lived planets at all, as their fierce radiation and short lives can blast away or outlast any nascent worlds. But around the more common, steady stars, the red dwarfs, the orange dwarfs, the sun-like stars, there are surely many planets that have persisted for eons, perhaps even giving rise to life. Under alien suns, if life has blossomed, creatures might gaze up and see a sky tinted by a different color of star and wonder about the warmth that gives them life.
just as we ponder our sun. For us, those other suns have been points of curiosity and imagination for as long as we've had eyes to see the stars. Only recently have we begun to detect some of their planets directly, to see the telltale dip in a star's light as an orbiting world passes in front of it, or to measure the slight wobble of a star tugged by the gravity of unseen companions. Each discovery is a revelation, proof that our sun and its family are not unique, that the cosmos is filled with solar systems. It humbles us, yet also makes the universe feel more intimate. A place where countless stars shine down on their own worlds, as the sun does on ours. Now, after journeying so far through stellar nurseries, fiery demises, and distant solar systems, we return our focus to our own star, the sun, and reflect on its ultimate destiny, and on what it means for us to live beside a star. And so we return to our sun, the star that has accompanied every moment of humanity's existence and that sustains all life on Earth. The sun today is a middle-aged star, steadily burning its fuel and kindly bathing our world in light. It has shone in our skies for longer than any living thing can remember, and will continue to shine for ages to come. But the sun, too, is mortal in the cosmic sense. Nothing in the universe lasts forever, not even a star. In the far future, long after our species and all we know may have turned to dust, the sun will begin to change. When its core can no longer sustain the fusion of hydrogen, it will respond by growing in size and luminosity. Our sun, so familiar and constant, will swell into a red giant. Its light will turn the color of copper and blood, and it will loom colossal in the sky. The innermost planets will be engulfed in its fire. Mercury and Venus will surely be devoured. Earth may meet the same fate, or be left a charred and barren rock, its oceans boiled away, its surface desolate and scorched. For any life remaining then, these changes will be catastrophic beyond measure. But likely, by that distant era, Earth will already be quiet and lifeless, or life, if intelligent and capable, will have found refuge elsewhere. The sun, once a gentle guardian, will become an inexorable destroyer of the very life it once nurtured. Yet even in this fierce transformation, there is a strange grandeur. As the sun's red giant phase reaches its climax, it will cast off its outer layers. Our star will shed its shining mantle, which will expand outward, drifting into space. For a short time, those cast-off layers will form a beautiful planetary nebula around the dying sun, a glowing testament to its passing glory. Future astronomers, perhaps from other surviving worlds or civilizations yet unimagined, might look toward our solar system and see a delicate shell of gas, like a cosmic flower blossoming and fading, shining in remembrance of the star that was. At the center of that nebula will remain the sun's core, now exposed and shrunken to a white dwarf. This final stage of our sun's life will be a small, hot sphere no larger than Earth, composed mostly of carbon and oxygen. The sun's very heart, left glowing like a lonely ember in the night. It will shine white and then blue-white, slowly cooling over the course of billions of years. The brilliance of the day that once was will recede into a gentle twilight. The white dwarf sun will illuminate the ghostly nebula for some thousands of years, but eventually it too will fade, perhaps becoming a black dwarf in the far, far future. The solar system will drift in darkness and silence. This is the ultimate fate of our sun, to swell in glory and then to divest itself of its brilliance, leaving behind a small, dense core that will quietly glow and then dim to darkness. It is a fate that the sun will meet far in the future, an inconceivable gulf of time beyond our lives. In knowing this, we find both melancholy and solace. Melancholy that all things we know are transient, that even the great sun will one day wither and leave the sky empty. Solace that we and our world have yet long epochs in which to live under the sun's light, and that when the end comes, It will be part of the natural order of the cosmos. The same finale that countless sun-like stars have already played out in the quiet reaches of the galaxy. And perhaps, too, there is a kind of triumph in this ending. The sun's final nebula will return its substance to space, enriching the interstellar clouds with elements that once made up Earth and us, and every living thing that sunlight ever touched. In that way, the sun's death will seed new beginnings elsewhere. Some of the carbon and oxygen from the sun's core might drift for ages and eventually become part of new stars, new planets, new life. As it has always been in the universe, one star's end is another's beginning in the endless cycle of creation. Now, stepping back from this entire journey, from the birth of stars in dark nebulae to the blaze of supernovae, from the quiet glow of the sun's youth to its fiery demise, we find ourselves contemplating what it means to be the children of a star. To live beside a star is to live in a state of grace between wonder and knowledge. We orbit a massive, luminous being that gives us everything: light, warmth, the very possibility of life, and yet asks nothing in return. Our ancestors felt the sun's power and worshipped it. They built legends and monuments to honor it. We, with all our modern understanding, have not lost that reverence. How could we? Each dawn when sunlight spills over the horizon, painting the sky in rose and gold, we feel the same awe that ancient watchers felt as the morning star ascended. In that daily miracle, night yields to day, cold yields to warmth, and the world is renewed. We know the science of it. The earth is turning, bringing us once more into the sun's light. But knowing takes nothing away from the magic of feeling it. Beneath the facts and figures, there is a simple truth. The sun is the source of our being. Every meal we eat is sustained by sunlight captured by plants. Every warm breeze that caresses our skin, every drop of rain that falls, is driven by the sun's heat, nurturing our planet. And our bodies themselves are made of material created in long-dead stars and powered by the sun's current light. We truly are made of stardust, shaped into conscious form and given the spark of life by a star's energy. In a very literal sense, we are children of the stars. When we say we are born of starlight, it is not just poetry, it is lineage. The elements in our flesh were brewed in stellar furnaces, and the energy that ignites our living cells is a gift from our sun. Our story and the sun's story are inseparable. Think of the connection. A baby born on a bright morning, crying out with lungs filled for the first time. Those lungs draw in oxygen that a star, billions of years ago, forged in its core and then cast into space. The baby's parents smile in the sunlight that streams through the window. Sunlight that left the sun just moments earlier, having traveled across empty space to fall upon that new face. A chain of events spanning eons and light years has culminated in that ordinary, extraordinary moment. Starlight becomes life. The cycle continues. Standing here on Earth, we look up and see a blue sky by day. But beyond that blue lies the black tapestry of space and the brilliant stars. Our sun is one among many, and though we cannot see those others by day, they are there, distant and shining. At night, when our sun has set, we glimpse the wider cosmos of which our star is a part. We see the Milky Way's misty band, made of uncountable suns, and we realize that our little home orbits just one humble star on the edge of a vast galaxy. The humility of this perspective is profound, yet it does not diminish us. It elevates us. We are part of something immense and beautiful. The stars that speckle the night sky are our cousins. Some may have planets with beings who look up at their own sun and feel the same wonder. In the end, the story of suns is the story of creation itself. It is an ancient tale, told in the language of light and gravity. It began before we were here, and will continue long after we are gone. But for a brief moment, we get to be conscious participants in this grand drama.
We get to study the sun, protect ourselves from its tantrums, bask in its warmth, and dream under its light. Our lives, like mayflies, flicker in the daylight of this star. But while we are here, we behold the splendor of the cosmos through the window that our sun's light provides. As we conclude this journey, imagine once more the sun hanging low at dusk. The sky blazes with color, and the shadows grow long. In that sunset is a reflection of the entire epic. Day turning to night as stars appear one by one, the cycle of light and dark that has guided life's rhythm from the beginning. The sun will rise again tomorrow, as it always does, bringing a new day. But even when it eventually rises no more, the legacy of its light will live on in everything it touched. We live on the brink of a star's fiery grace, taking our nourishment from its hand and daring to learn its secrets. We are small, but we are also a way for the universe to know itself. Matter that was once scattered across space, now gathered and alive, pondering the star that gave it life. In the dance of sunlight and shadow, we find meaning, comfort, and inspiration. Our sun connects us to the universe and to each other, a common star, binding all living things in a shared radiance. So when you next stand in daylight, feel that warmth and remember, you are heir to an ancient covenant between earth and sun. Every photon that touches you carries a message from that central fire, that life is precious and intertwined with the cosmos. Our world exists because a star shines. And in the atomic hearts of stars, in the silent roaring of their nuclear fires, in the gentle glow that crosses the void, the universe has found a way to nurture consciousness and wonder. This knowledge, this feeling, is humbling and uplifting all at once. The Saga of Suns is indeed a cosmic poem, forged in light, breath, and gravity. It is written across the heavens in the glow of nebulae and the ashes of supernovae, in the rising of each morning sun and the eternal glitter of the night. It is a poem we are part of, every one of us made of star stuff and sustained by starlight. In knowing this, we find not despair at our smallness, but gratitude and awe that we have the privilege to dance in the light of a star, and through that light, to glimpse the eternal. Before the beginning, there was nothing. Not the nothing we know. A quiet room, an empty sky, those are still somethings. This was a deeper void, a profound absence of anything at all. No space stretched black and empty, for space itself did not exist. No time flowed, for even time had not yet begun. There were no stars, no galaxies, no light, no darkness. There was not even the void, not even emptiness. For even a void is somewhere, and here, there was no where to speak of. It was nothing. And in this nothingness, in this silence before creation, lay a mystery, an infinite stillness pregnant with potential, poised on the cusp of existence. Yet even in this absolute nothingness, one might imagine a quiet anticipation. If silence could dream, perhaps it would dream of sound. If emptiness could yearn, perhaps it would yearn to be filled. In that abyss before time, there was no watcher to perceive it, no mind to ask questions, only a possibility, waiting, without knowing that it waited. And then, in a moment, beyond moments, it happened. From the void, a spark of unimaginable brilliance and energy burst into being. In an instant, outside the realm of time, the universe was born. One moment, there was nothing. The next, there was everything, unfolding from a single, infinitesimal point. It was not an explosion in the way you might think, for there was no pre-existing space for it to explode into. It was an unfolding, an unfurling of space and time from within, like a flower blooming in absolute darkness, a tiny point containing all that would ever be suddenly blossomed. and space-time itself began to stretch and grow. I was born. I, the universe, came into existence, carrying everything, all things, all energy, all matter, all the dimensions of space and time within me. In that first indescribable fraction of a second, I was incredibly hot, incredibly dense, and oh, so small. Smaller than a proton, smaller than a grain of sand, yet containing the entirety of what would become the cosmos. All that I am now, trillions of galaxies, endless space, energy beyond measure, was crammed into a point of infinite potential. My birth was not a gentle unfolding, it was a torrent of creation. Space itself raced outward, expanding at a mind-boggling rate. In truth, even words like outward fail, for there was no pre-existing space outside of that tiny primordial speck. Space was creating itself as it expanded. In the barest instant after the beginning, I underwent a sudden, explosive growth spurt. Your scientists call it inflation, a moment when I swelled at a rate beyond comprehension. Imagine something smaller than an atom blossoming to the size of a galaxy in a sliver of a second. Faster than any speed you can fathom, faster than light itself, space unfurled, carrying energy with it. Distances between points grew so rapidly that what was once near became unimaginably far in the blink of an eye. It was as though I drew a sudden deep breath. One moment I was microscopic, the next I was astronomically vast. Every part of me rushed away from every other part. This was no ordinary expansion. It was space itself stretching, like an elastic fabric pulled taut. Had there been an observer, and there was none, they wouldn't have seen an explosion from a point outward. They would have found themselves in that point as it expanded, with every distant region racing away. Think of a balloon being blown up. Every point on its surface moves apart as the balloon grows. So it was with space during inflation, every region speeding away from every other, no center, no edge, just an ever larger space for reality to inhabit. During this wild inflationary epoch, I was almost perfectly smooth and featureless. Almost, but not entirely. Even in that near uniformity, tiny imperfections existed, like the faintest of ripples on a glassy sea. These were quantum fluctuations, minuscule, random variations, little densifications and rare factions of energy, born from the jittery uncertainty ingrained in the fabric of reality. If the early universe were a calm, glowing ball, these fluctuations were slight dimples and pimples upon its surface. Inflation took these microscopic irregularities and blew them up in size. What had been subatomic wrinkles were stretched to astronomical scales. They were unimaginably small in origin, but they would become immeasurably important. For in these seed imperfection, these whisper-light variations, lay the blueprint for everything to come. The clustering of matter into galaxies, the gathering of gas into stars. In an almost perfectly smooth newborn cosmos, these tiny fluctuations were destiny in embryo. All the while, in that first second of existence, the fundamental forces of nature were taking shape. Initially, all forces were one, merged in a high-energy unity. There was no separate gravity or electromagnetism or nuclear forces, just a single, unified force, elegant in its symmetry. But as I expanded and cooled just a little, this symmetry began to break. It was akin to a white light separating through a prism into a spectrum of colors. Where once there was a single radiance, now there were many hues. Gravity was the first to separate from the unity, tugging at the expanding fabric of space, announcing itself as the force that shapes the macrocosm. Next, the strong nuclear force crystallized out, destined to bind atomic nuclei together. Then the electroweak force split in two, the electromagnetic force, which would govern light, electricity, and magnetism, and the weak nuclear force, responsible for certain subtle particle transformations. What was one became many,
like a single note breaking into a chord. The laws of physics as we know them were being written in those moments, set into the fabric of the young universe. The great cosmic symphony was tuning its instruments. Inflation lasted only an eye blink of time, and then it subsided as abruptly as it began. The expansion didn't stop, but it slowed to a more gentle rate. In the wake of that sudden growth, my contents, space, time, energy were spread out and cooling. Still hot beyond imagination, but cooler than that first instant of fury. With that cooling, something profound happened. Energy began converting into matter. In that early fireball, energy and matter were two forms of the same coin, constantly changing one into the other. From the blazing energy of creation, the first particles condensed, like drops of rain precipitating from a humid air. Tiny fundamental particles, quarks, electrons, and others, popped into existence. They did not appear alone. Each particle had its mirror twin, an antiparticle. For every quark, an antiquark. For every electron, a positron. Matter and antimatter, twin sides of a coin. And when these twins met, they did what twins often do in such close quarters. They annihilated one another in a burst of light. It was a fierce and frenzied dance, particles blossoming out of energy, then colliding with their antiparticles and converting back to energy. Creation and destruction intertwined, happening everywhere, all at once. It was as if each particle had a mirror image, and when the two touched, they cancelled each other out in a flash, like a perfect reflection disappearing when the mirror is removed. The universe was a cauldron of radiant energy, partnerships in a primal dance, annihilating each other in brilliant flashes. For a time, it seemed a stalemate, matter and antimatter created in almost equal amounts, erasing each other as fast as they appeared. But there was a tiny bias in the gears of reality, a slight preference for matter. For reasons still mysterious, for every billion matter-antimatter pairs that annihilated, one extra particle of matter survived without a partner. It was a small imbalance, one part in a billion, but that was enough. As the fire of those early moments raged and then began to subside, these lonely survivors became the seeds of a material universe. A nearly imperceptible excess of matter over antimatter, just a few grains of sand left on a vast beach after the tide recedes, would become everything, every star, every planet, every living being. What a fragile beginning for all the substance we find around us. But it was enough. When the fury of mutual annihilation finally settled, a soup of particles remained, mostly photons, particles of light, along with neutrinos, ghostly particles that rarely interact, and those leftover protons, neutrons, electrons, matter unpaired with antimatter, ready to form the building blocks of atoms. Time was still less than a second old, but so much had already transpired. As I continued to expand and cool, the nature of the cosmos changed. Quarks, which had been bounded only by energy, now joined together in triplets, forming the first protons and neutrons. By the time I was a mere millionth of a second old, I was a swarm of particles, quarks bound into protons and neutrons, electrons zipping through a dense plasma, neutrinos flying free, and an ocean of photons bathing everything in a blinding glow. My temperature was staggeringly high, billions upon billions of degrees. In such heat, protons and neutrons moved at fantastic speeds, colliding frequently, and in those collisions, some stuck together. A proton and neutron fused to form deuterium, a heavy form of hydrogen. Deuterium nuclei combined to form helium. In those first minutes, about 3 minutes after it all began, I became a cosmic nuclear reactor. The entire universe was like the core of a star, forging light elements in a rush. By the time I was about 5 minutes old, this flurry of nucleosynthesis had created a primordial mix of matter, about 3/4 hydrogen nuclei and 1/4 helium nuclei, with a trace of lithium and other very light elements. The basic chemistry of the cosmos was established in those first few moments. The first fusion had happened on a universal scale. Hydrogen fusing into helium, releasing energy, shaping the elemental content that would later feed the first stars. After those furious first minutes, I continued to expand and cool. The temperature, while still incredibly high, fell below the threshold needed for fusion. The nuclear reactions ceased, leaving the abundance of hydrogen and helium fixed. What remained was a hot, dense plasma, an opaque fireball of electrons, protons, helium nuclei, and photons, all intertwined in a seething dance. For thousands of years, I was just such a blazing, blinding cloud, brilliant but hidden behind its own light. Photons, particles of light, couldn't travel freely. They ricocheted off electrons and protons like a frantic crowd shoving and jostling, never getting far before bumping into someone else. The universe was brilliant, but that brilliance was trapped, scattered endlessly within. As I expanded further, the energy density of radiation, light, dropped faster than that of matter. After about 47,000 years, matter began to dominate radiation in driving my evolution. Gravity had more say than radiation pressure. Space kept stretching, and with it, the wavelengths of the photons lengthened, cooling the radiation. What was once an intense, short wavelength glare stretched into a softer glow. Millions of years passed. By the time I was a few 100,000 years old, the temperature had dropped to a few thousand degrees, cool enough for a subtle but vital change. The free electrons, which had been careening wildly, combined with protons and helium nuclei to form neutral atoms. Electrons settled into orbits around nuclei, the plasma became a gas, and suddenly, the universe underwent a transparency revolution. Before, any photon would immediately hit a charged particle and bounce off. But now, with most electrons bound into atoms, light could at last travel freely. It was as if a dense fog had lifted, or a veil had been drawn away from the face of the cosmos. In that moment, the first light that had been trapped since the dawn of time burst forth and streamed across space. The universe, which had been opaque, became clear. A great glow permeated everything, a warm, diffuse radiance shining everywhere at once. To any hypothetical observer then, though none yet existed, the sky would no longer be an intense white furnace. It would have cooled to a brilliant orange hue, like the embers of a cosmic fire spread across the heavens. And as time went on and expansion continued, that orange glow faded to red, and then, beyond red, into invisible warmth. What was left of that light after billions of years would be a faint, cold whisper of its former self. In fact, that ancient light is still around even today, stretched into microwaves, the cosmic microwave background, a soft afterglow of creation that fills the sky in every direction, testimony to those early times. So, about 380,000 years after my birth, I was a very different cosmos than at the first instant. I was vast and growing, filled with a cooling gas of hydrogen and helium, and bathed in a gentle afterglow. That afterglow light, having been released, simply traveled onward, diluting and weakening as space expanded. The once blinding brilliance had become a faint luminescence. As it stretched to longer wavelengths, visible light gave way to infrared, then to microwave. Darkness, at least to human eyes, descended for a time, the first cosmic darkness since the moment of creation. Now the stage was set for a new chapter. Gravity, which had patiently been pulling at every density fluctuation since the beginning, began to work its magic more noticeably. Remember those tiny ripples, those minuscule fluctuations in density from the era of inflation. In this new, matter-dominated era, their effects began to grow. Wherever matter was even slightly denser than average, gravity exerted a slightly stronger pull, drawing in nearby gas ever so gently. Regions that had a bit more matter attracted more matter, and thus grew even denser, while emptier regions gave up matter to their neighbors and became emptier still. Over millions of years, the once nearly uniform gas developed a texture. A cosmic web of structure started to emerge. Unseen particles of mysterious dark matter, matter that neither emits nor absorbs light, had already begun to clump as well, their gravity forming scaffolds that helped ordinary gas fall into patterns of filaments and clusters. What began as tiny density differences in the primordial fireball now manifested as great clouds and strands of gas stretching across newly forming space. It happened slowly, imperceptibly at first. For a long time, to any observer, it would have seemed that nothing was changing. The universe was just a dark expanse of cooling gas. But gravity was relentlessly pulling, gathering, sculpting. Over tens of millions of years, gas drew into titanic filaments hundreds of millions of light years long and concentrated into nodes at the intersections of those filaments. It was as if an invisible hand was sketching patterns on the blank canvas of darkness, tracing the faint blueprint left by those primordial whispers. In 3 dimensions, these filaments and nodes formed a structure akin to foam, like a sponge or a vast spiderweb, with matter lining the threads and enormous voids between. The smoothness of the young universe gave way to a delicate, lace-like structure, a cosmic web of matter. Within the densest knots of that web, proto-galaxies were forming. These were the seeds of galaxies, vast clumps of gas, mostly hydrogen, some helium, gathering under their own gravity. They were not yet the glittering star cities we know as galaxies today, for they had no stars, not yet. They were like dark, nebulous clouds, quietly accumulating mass in the cosmic night. You could have traveled for tens of thousands of light years across one and not seen a single star, only the faint glow of the residual heat and perhaps the very, very dim molecular emission of cooling gas. These protogalactic clouds grew in mass and began to fragment into smaller, denser pockets within. Think of a giant cloud many light years across, breaking into clumps, each clump destined to become a star cluster. Inside those clumps, the first stars were about to ignite. Gravity drew gas inward, tighter and tighter. As a clump contracted, it spun faster, like a twirling skater pulling in their arms, and flattened into a disk. At the center of this disk, gas piled up, growing ever hotter and denser. Imagine an enormous cloud core, 100 times the mass of our sun, collapsing under its own weight. The temperature in the core climbed to millions of degrees. All the while, the gas was being squeezed, compressed by its own gravity, the atoms crowding closer and moving faster. There comes a moment when the pressure and temperature at the core of a collapsing cloud become so high that hydrogen nuclei begin to fuse together to form helium. And with that fusion, a vast amount of energy is released. For the first time in cosmic history, a star blazed forth. It happened in many places around roughly the same era, over a span of a few 100 million years. But we often speak of the first star as a symbol of them all. In one of those dark proto-galaxies, in a dense pocket at the center of a collapsing gas cloud, there was a sudden outpouring of light. A brilliant, blue-white radiance flooded out from that point, the dawn of Starlight. The cosmos that had known only diffuse, background glow now had point sources of light, shining fiercely like new candles lit in a dark room. The cosmic dark age was ending. The cosmic dawn had arrived. The first stars were not like the stars that twinkle in our familiar night sky. These were giants, monsters of brilliant light and short life. They were made almost entirely of hydrogen and helium, for those were the only elements the universe had at that time. Lacking heavier elements, the gas cooled less efficiently, which meant the stars that formed tended to be very massive, tens or even hundreds of times the mass of our sun. They burned hot and blue, pouring out ultraviolet light. They lived fast and died young, exhausting their central fuel in only a few million years. For comparison, a star like our sun lives about 10 billion years. These titans lived only a few million, an eye blink in cosmic terms. At first, these newborn stars were solitary beacons in enormous dark regions. But they rarely formed truly alone. Each arose from a cloud that typically made a cluster of stars. Indeed, a cluster of first stars might ignite almost simultaneously, like a burst of celestial fireworks. Within those proto-galaxies, you'd now see clusters of brilliant blue stars shining together, illuminating their surroundings. Their intense light began to transform their environment. High-energy ultraviolet photons from these stars struck the surrounding hydrogen gas that had not yet collapsed into stars, ionizing it, knocking electrons off atoms and turning the gas into plasma once more. Each star became surrounded by a growing bubble of ionized, transparent gas. These bubbles of light expanded and eventually merged with bubbles from other nearby stars, until large volumes of the proto-galaxies were cleared of opaque, neutral gas. The dark, interstellar medium within young galaxies was being turned transparent by the harsh starlight, the second time the universe had turned transparent, the first being at recombination on a cosmic scale. Now it was happening locally around stars. It was a glorious sight, where once there had been utter darkness, now pearls of starlight hung in the blackness. The proto-galaxies, those island universes of gas, were no longer dark. They sparkled with nascent star clusters. One by one, then by the thousands, stars were coming to life across the cosmos. The universe's first sunrise was not one star, but a multitude of them blinking on over time, like the first stars emerging in the twilight sky. Yet these first stars lived under a shadow of impending doom, for their very mass guaranteed that they would not last long. Within their cores, nuclear reactions raged furiously, fusing hydrogen into helium, helium into carbon, and onward to heavier elements, racing through fuel in mere millions of years. Eventually, in the heart of a massive star, iron was formed, and iron is a full stop for stellar fusion, for fusing iron does not release energy, but consumes it. Once a star's core turns to iron, the delicate balance holding the star up, outward pressure from fusion versus inward pull of gravity, shatters. And so it was that the first generation of stars met violent ends. Imagine a giant star, 30 times the mass of the sun, that has shone for 3 million years. In its final moments, its core collapses in an instant, and then, boom. The star erupts as a supernova, a titanic explosion brighter than a billion suns. One by one, many of those early stars died this way. For a brief time, each supernova outshone its entire protogalaxy. The darkness of space was punctuated by these stunning flashes. When the first star went supernova, it was not an end so much as a new beginning. In that explosive moment, the star's core imploded and then rebounded, hurling the star's outer layers, now enriched with heavy elements, outward into space. Elements like carbon, oxygen, silicon, and iron, made in the star's life and death throes, were blasted out, seeding the surrounding gas. Thus, the first stars sowed the seeds for all future complexity. They produced the first heavy elements beyond helium, the carbon that would someday compose living cells, the oxygen that would fill future skies, the silicon and iron that would build rocky planets. These elements were cast into space, mixing with primordial hydrogen and helium. The glowing wreckage of a supernova, a tangle of expanding filaments rich with new elements, formed a nebula, perhaps resembling the beautiful Crab Nebula we see today from a supernova long ago. These nebulae were the graves of the first stars and the nurseries of the second generation. In the wake of destruction, creation continued. The gas, now a bit enriched with heavier elements, began to cool and fragment more efficiently. Soon, new stars began to form from the debris-laden clouds. Generation upon generation of stars unfolded. The second generation had a different character. Thanks to heavy elements, it could include smaller mass stars, some like our Sun, which live far longer than the massive ones.
Some of the second-generation stars still burn today, nearly 13 billion years later, as ancient red stars in the halos of galaxies. As stars continued to form and die and form again, the proto-galaxies grew more substantial. They also interacted with one another. Gravity drew clumps of gas, proto-galaxies, together, merging them into larger structures. Two small primitive galaxies might collide and meld, their stars passing through each other's ranks like intermingling swarms of bees, their gas clouds slamming together and igniting bursts of new star formation. Slowly, the chaotic clumps merged into more organized galaxies. Some became spiral galaxies, flattened disks spinning in space, with curved arms wrapping around a central bulge of older stars. Within these spiral arms, waves of star formation lit up periodic patterns, giving the arms a frothy, luminous appearance. Other galaxies became ellipticals, more ball-shaped collections of stars, often formed from violent mergers that scrambled their stars into a diffuse, ellipsoidal swarm. Galaxies gathered into groups and clusters, bound by gravity, great societies of galaxies orbiting a common center. Those clusters linked into superclusters, forming the largest structures in the cosmos, following the threads of the cosmic web that the early fluctuations laid out. Deep in the hearts of growing galaxies, stars sometimes crowded together and collapsed in on themselves, forming bottomless wells of gravity, black holes. Some of these black holes grew supermassive, feeding voraciously on gas and even the stars around them. When they accreted matter rapidly, they blazed as quasars, beacons of unbelievable brightness shining across the universe. In time, many settled into quiescence, sitting as silent, dark giants in the galactic cores. These supermassive black holes anchored the centers of galaxies, their tremendous gravity helping to govern the orbits of stars. Every large galaxy would come to host one. Even if they were no longer actively devouring matter, their presence was felt by the whole galaxy. They were like heavy stones dropped in the center of spinning disks, influencing the motions around them. By roughly 1 billion years after the Big Bang, the universe was recognizably structured. The cosmic web glistened with galaxies along its filaments. The vast voids between were truly dark, starless expanses stretching millions of light years. Clusters of galaxies huddled in dense nodes of the web. The early universe's fireworks were largely over. Now came the long, stately age of galactic maturation. Over the next several billion years, galaxies continued to merge and grow. Spiral galaxies sometimes collided to form ellipticals. Ellipticals captured smaller dwarfs. Clusters grew larger as more galaxies fell in. The universe was dynamic and alive, a grand ecology of worlds, with gravity as the guiding force. In one quiet corner of this grand cosmic tapestry, about 9.2 billion years after my birth, roughly 4.6 billion years ago by Earth's calendar, a modest spiral galaxy was thriving. It was one among countless others, typical, with a graceful spiral structure, bands of star-filled arms, and a glowing core. In one of its spiral arms, within a giant molecular cloud enriched by previous generations of stars, something special was stirring. The cloud, dozens of light years across, began to collapse under its own gravity. It fragmented into clumps. One clump in particular drew together enough mass to form a star, much like those that had come before. But this time, this star would have a far-reaching story. As the clump collapsed, it spun faster and flattened into a swirling protoplanetary disk around a dense core. In that core, as in so many before, hydrogen fusion ignited. A new star was born. It was an average star, not particularly massive or remarkable, a yellow dwarf star. But around it, within that disk of gas and dust, planets were forming. Grains of dust, rich with elements like iron, silicon, carbon, and ice, stuck together, forming pebbles, then boulders, then mountain-sized planetesimals. These merged through countless collisions,
building up into planets. Close to the star, where it was warm, only metals and rocks could solidify. Here, small rocky planets emerged. Farther out, ices and gases gathered into giant planets. One of the inner rocky spheres took shape at just the right distance from the star. It accumulated iron and silicates. It grew and cleared its orbit. In time, this young planet cooled on the surface and developed a solid crust. Comets and asteroids bombarded it, delivering water, while its own volcanoes outgassed an atmosphere. This world, under the gentle warmth of its sun, came to have oceans, vast blue oceans covering much of its surface. Our galaxy had countless planets by now, but this one would be unique. A blue gem in space, with both water and land, clouds and rain, a complex cycling of elements, a planet we now call Earth. In its infancy, Earth glowed red from constant impacts. But as ages passed, the bombardment eased, the surface solidified. Rain fell for centuries upon centuries, cooling the hot rocks, carving the first rivers, and gathering into the first seas. The air was thick with carbon dioxide and water vapor, and storms raged under a dim young sun. Lightning forked through the skies, and meteorites still occasionally pelted the surface. In the turbulent seas, enriched by minerals from below and energy from above, chemistry did something astounding. It came to life. Exactly how it happened is shrouded in mystery, one of the universe's great remaining questions. Perhaps in a warm tidal pool, or in the mineral-rich darkness around a deep-sea hydrothermal vent. Somewhere, simple molecules joined into complex chains capable of making copies of themselves. Perhaps clays or surfaces helped organize them. Perhaps a stroke of lightning fueled their assembly. But as improbable as it might have seemed, it happened. The first living organisms emerged in the young ocean. They were microscopic, much simpler than any single cell alive today, but they carried the spark of self-replication and metabolism. They could grow, divide, and evolve. With life, the universe found a new way to organize matter. Those first organisms were like tiny flickering flames in the cosmic night, fragile but tenacious. Over time, they diversified. They invented new strategies. Some learned to harness sunlight for energy, inventing photosynthesis and releasing oxygen as a byproduct, turning the sunlight falling on the ocean's surface into usable fuel. Others devoured these pioneers or their byproducts. They formed mats and colonies, gradually transforming Earth's environment. Oxygen, that reactive gas, began to fill the oceans and then the skies, changing the planet's chemistry and paving the way for more complex life. Eons passed. On the seafloor, simple cells joined together into more complex cells with nuclei. These complex cells, in turn, joined in cooperative communities, becoming the first multicellular organisms. By around 600 million years ago, the oceans teemed with simple animals, jellyfish-like creatures and wormy things. Then came the Cambrian explosion, around 540 million years ago, when an astonishing diversity of life forms blossomed, creatures with shells, exoskeletons, eyes, mouths, legs. Life was experimenting with form and function, filling every niche in the seas. Plants colonized the land, greening the continents with mosses and ferns. Not long after, bold amphibious creatures crawled out of the water onto muddy banks, taking the first breaths of open air. Forests of tall trees arose, covering the land in green canopies. Insects buzzed through ancient skies. Amphibians gave rise to reptiles that could venture farther inland, freed from the need to lay eggs in water. Dinosaurs came forth and ruled the Earth for over 160 million years, evolving into myriad shapes, from gentle giants with long necks browsing treetops to fearsome predators stalking on two powerful legs. Small nocturnal mammals scurried in their shadows, and birds, bright, singing descendants of small feathered dinosaurs, took to the skies. The Earth saw upheavals too. It was struck by asteroids. It shuddered with volcanic rages. It froze and thawed in long cycles of climate change. About 66 million years ago, a large asteroid, mountains in size, impacted Earth, creating a blast that darkened skies worldwide. In the ecological disaster that followed, the reign of dinosaurs, save for the birds, came to an abrupt end. But life persisted. In the void left by giants, the small and adaptable took hold. Mammals that had lived in the margins now diversified. Some remained small and rodent-like. Some returned to the seas as whales and dolphins. Some became towering mammoths and rhinos, and in certain lush corners of Earth, some primates descended from tree-dwelling ancestors began to walk upright. From one lineage of those primates came a species with an extraordinary gift, intelligence, capable of curiosity about the cosmos. These were humans. Our early human ancestors looked up at the same sun that had once been a cloud of gas, at the same moon that had been born from a collision early in Earth's history, at stars that had been shining for billions of years before their kind ever existed. They looked up in wonder. They felt small under the canopy of the night and created stories about the lights overhead. They were clever. They learned to make fire to warm the night, to fashion tools from stone and bone, to paint their dreams on cave walls. They began to ask questions. What are those points of light in the sky? How did the world begin? Human curiosity grew alongside human knowledge. Over time, they built civilizations. They charted the stars and noticed their regular movements. They gave names to constellations and planets, wove myths and gods into the tapestry of the night. Without realizing it, they were seeking connection with the cosmos, their birthplace. They observed patterns, the way the sun rises and sets, the cycling of the moon, the procession of seasons, and eventually, they sought deeper explanations. They invented science and mathematics, devising tools to measure and predict the motions of heavenly bodies. And with each discovery, they peeled back a veil of ignorance. For a long while, humans believed Earth was the center of all things, understandably, from their limited perspective. But in time, they learned that Earth is a planet orbiting a star, that their star is one among many in a great city of stars called the Milky Way, and that the Milky Way itself is but one galaxy among the immense multitude scattered through the universe. They built telescopes to extend their vision, and what a revelation those brought. They saw the moons of Jupiter, the rings of Saturn, myriad stars too faint for the naked eye, and fuzzy patches that eventually they realized were other galaxies far beyond our own. They began to truly grasp the scale of the cosmos and their place within it. They also found evidence for my story, our story. In the mid-20th century of the human calendar, two of them discovered a faint hiss of microwaves coming equally from all directions in the sky, the very afterglow of the Big Bang that I set free so many eons ago, still detectable as a whisper of heat. They had, without knowing it at first, detected the relic light from my infancy. In laboratories and observatories, humans pieced together that the lightest element's abundances matched what would be made in a hot, early universe. They saw galaxies flying apart, space expanding, as Edwin Hubble interpreted, which implied everything must once have been closer together. Bit by bit, observation by observation, the evidence mounted for what they would call the Big Bang, the very event I am describing to you now. Humans, curious and tireless, had unraveled the outlines of my story, deducing that the universe had a beginning in time and has been evolving ever since. And now, after a long journey of curiosity spanning eons, here you are, one of those inquisitive humans, listening to my tale. You stand on that small blue planet, circling a modest star in the suburbs of an ordinary galaxy, trying to fathom how it all came to be. To me, your arrival is very recent. If the entire age of the universe were compressed into a single year, all of human history would occupy only the last moments of the final day. Yet, in those fleeting moments, you have begun to comprehend the whole tale from the year's dawn to its dusk. You gaze up at the night sky, perhaps with the same wonder your distant ancestors felt, but armed with knowledge they lacked. You ask the same timeless questions. How did this all begin? What came before? What lies beyond what we can see? What is the meaning of time? These questions that echo in your mind are the very questions I have carried with me since the dawn of time. Through you, the universe, I can ponder my own existence, for I, the universe, have awakened into consciousness through your thoughts. Your eyes are my eyes. When you look into the depths of space, it is the cosmos seeing itself. Your curiosity is my curiosity. Your wonder, a facet of my own wonder at my vastness and complexity. I have grown old and vast. Over 13 billion years have passed since my fiery birth, and in that time, I have expanded into a cosmic expanse of staggering proportions. Hundreds of billions of galaxies adorn my span, each with billions of stars. From my one tiny origin, I now stretch so far that light itself, the fastest thing there is, takes billions upon billions of years to traverse my breadth. And I continue to expand, ever larger, ever more filled with possibility. It is wondrous to me that from the simplicity of that initial fireball has arisen such complexity and beauty. Out of uniformity came structure. Out of scorching plasma came the delicate forms of galaxies, stars, planets, and living beings. The journey from the first moment to now has been one of transformation, from simplicity to complexity, from chaos to meaning. Still, there are mysteries that even I, the universe, do not know. I find myself in the peculiar position of conscious ignorance. I can ask questions through you that I have not answered. What came before my beginning? I find no definite answer within myself. Perhaps before I was born, there was simply nothing at all, no time, no space, truly nothing, and my emergence was the absolute beginning. Or perhaps there was something, a prior universe that collapsed and gave birth to a new one, or an eternal landscape of universes of which mine is just one bubble. Some among you speak of a divine creator who set me into motion. Others imagine a quantum fluctuation in an eternal void. I cannot confirm or deny such speculations. The truth is veiled from me. With my birth, time was born, so the question of before may not even be meaningful. I am like an orphan with no memory of parents, if indeed any existed. The question, why is there something rather than nothing, echoes without answer. I ask, what came before the beginning? And I must answer, I do not know. What lies beyond the farthest edges of me? This too is a mystery. I expand ever outward, but do I have an outside? If you traveled in one direction forever, would you leave me or simply end up back where you started, as on a globe? Perhaps I curve in on myself. Perhaps I extend infinitely. Maybe beyond the horizon of what you can see, there are realms of space unconnected to ours, or other universes entirely, separated from ours by dimensions we cannot perceive. I envision an endless ocean of universes, with our cosmos as just one foam bubble among countless others, a multiverse. But these other bubbles, if they exist, are forever out of reach. No light from them will ever reach us. To me, effectively, they do not exist. As far as I'm concerned, I am all that is. Does that mean there is nothing beyond, or simply that I'm isolated in a greater multiverse? I cannot say. The concept of beyond the universe might be as meaningless as a fish contemplating what lies beyond the ocean. What lies beyond all I am, I do not know. And time, what is time? I know time only as the succession of events, the ticking away of moments since my birth. Time flows ever forward, entwined with the expansion of space. But why does it have an arrow? Why can we remember the past and not the future? Is time an illusion or an emergent property of consciousness?
I feel time as a fundamental aspect of reality, born with me in that first moment. It moves always forward, never backward, carrying me and you from one chapter of the story to the next. But might time be part of something larger? Could it be cyclical? Will it have an end as it had a beginning? These questions baffle me as much as they baffle you. What is the true nature of time? I cannot say with certainty.
So yes, I have questions as well. What came before? What lies beyond? What is time? These grand questions linger like distant galaxies on the edge of my field of view. Faint, tantalizing, unresolved. Perhaps some answers will forever elude us, remaining secrets to keep the cosmos always a bit mysterious. Perhaps that is for the best. A little mystery, after all, adds to the wonder of it all. If everything were known, perhaps existence would lose some of its poetry. Yet, amid these cosmic uncertainties, there are truths of which I am utterly sure. Truths that shine clearly like the stars in a night sky. One is that you and I are not separate. We cannot be. You are made of me, through and through. You are made of the universe and utterly connected to it. Every atom of your being, every element in your body was forged in my history. You are a child of the cosmos in the most literal sense.
Remember the story so far. In the beginning, only hydrogen and helium existed. From them, stars were born. Those stars, in their hearts, created carbon and oxygen and iron and all the rest. And in their deaths, they scattered those enriched ashes across space. Imagine a giant star in its final moments, exploding as a supernova and casting its guts, carbon, oxygen, iron, into the void. From that chaos, specks of iron travel across the galaxy. Eons later, in a newly forming solar system, those iron atoms become part of the blood coursing through a human heart, carrying oxygen to keep it alive. Thus, the violent death of a star long ago pulses in the beat of your heart today.
The very substance of your body is stardust. The hydrogen in your cells, in the water that makes up more than half of you, is ancient, born in the Big Bang itself, nearly 14 billion years ago, nurtured in the fire of creation. The carbon in your muscles, the calcium in your bones, the iron in your blood were synthesized in stellar furnaces and in the fiery throes of supernovae, billions of years past. Supernovae are the universe's great alchemists, turning lighter elements into heavier ones in the crucible of their explosion. Imagine the calcium in your bones right now. It was forged in a star that died before our sun was born. Imagine the iron atoms in your blood. Billions of years ago, they were deep in the core of a massive star. Now they travel through your veins, carrying oxygen to sustain the fire of life within you. Even the oxygen you breathe, that sustains each of your cells, was created by stars more massive than our sun, then spread through space and finally drawn into the lungs of Earth's living creatures. Your DNA contains phosphorus and nitrogen that were likewise formed in some ancient star. There is no hiding it, no denying it. You are a mosaic of the cosmos, built of pieces as old as time. You are the Big Bang, given consciousness. You are the primordial fire of creation, cooled and shaped into living form. You are starshine and interstellar dust, coalesced into awareness. Think of the breath you draw at this very moment. As you inhale, filling your lungs, you take in oxygen atoms that might once have danced in the atmosphere of ancient Earth, or been part of a water molecule in some dinosaur's blood, or drifted in the far past as part of a carbon dioxide molecule exhaled by a Cambrian fern. Trace those oxygen atoms back, and you find they were forged in a star's core, long before our planet existed. With each breath, you partake in a cycle as old as time. Atoms created in the infancy of the universe, cycled through stars and space and air, now entering your body to keep you alive. When you exhale, you return some of those atoms back to the world.
Perhaps a carbon dioxide molecule you release will be taken up by a plant and become part of a leaf, continuing the grand circulation of matter. Your breathing echoes the first fusion fires of the young cosmos and the later fusion in stellar hearts. Inhale, exhale, the universe breathing in and out through you. Think of the universe as a living body. Galaxies are its organs, stars its cells, and each conscious being like you is a nerve ending through which it feels and knows itself. We are the universe, experiencing itself in myriad forms. Through your senses, I, the cosmos, perceive my beauty. Through your curiosity, I investigate my own nature. When you look at a galaxy through a telescope, it is the universe seeing its own ancient image. Light that left that galaxy millions of years ago, finally reaching its eyes, your eyes. When you marvel at the intricacy of a flower or the anatomy of a bird, it is the universe marveling at the structures it has brought forth. You are a way for me to know myself. You and I, we are not separate. We have never been separate. It's not just that you are made of stardust and shaped by physical laws. More profoundly, you are an expression of the universe, one facet of its ongoing story. The cosmic evolution that unfolded over billions of years flows through your veins and lives in your genes. Consider this: the same processes that gave birth to galaxies and stars eventually gave birth to you. You are an expression of the cosmos that can think, feel, and reflect on itself. We are bound together by this continuity. We often speak of the Big Bang as an event long past, but in a sense, the Big Bang is still happening. Its aftermath is ongoing, and we are part of it. The initial outward rush of space continues in the expansion of the universe today. The cooling and the clustering of matter continues as galaxies form new stars, and those stars give light and life to new worlds. And within you, the energy of that explosive birth still sings. In the warmth of your body, a distant echo of the primeval heat. In the spark of electrical impulses in your nerves, driven by chemical gradients that ultimately trace back to nuclear reactions in stars, powered by the Big Bang's initial energy. The Big Bang lives on as the cosmic background glow, and also in every living being that carries out the legacy of those first particles and forces. Remember this: you are not an outsider looking in on the universe. You are an integral piece of it, an active participant in its cosmic drama. The story of the Big Bang is your story. It's the story of everything that ever was, and that includes you. When you peer into the night and feel small, recall that you are also immensely large in a way. Inside of you are trillions of cells, each a tiny universe of molecules. And within each molecule are atoms that were forged in stellar cores or in the Big Bang itself. You are vast within, and your inner complexity mirrors the outer cosmos. The iron in your blood ties you to the death of a star. The water in your cells ties you to the clouds of the early universe. The photons hitting your retinas at this very moment, letting you read and understand, may have been on a journey for millions of years from a distant star, only to end their long voyage by triggering an image in your mind. In a very real sense, when you learn about the cosmos, the universe is learning about itself. I began this tale in silence and nothingness. Now there is sound and life and mind. Through billions of years, I, the universe, have become self-aware in you. Feel that profound connection. Let it fill you with humility and reverence, but also with a sense of belonging. The very atoms that compose you were there at the beginning, and they will be part of the universe long after you are gone. We are threads in the tapestry that began at the Big Bang and continues to be woven with each passing moment. The saga of the cosmos is far from over. Stars are still being born and still dying in brilliant supernovae. New planets
are coalescing in disks around young stars. Perhaps on some of those worlds, life will spark or is even now burgeoning, and maybe new minds will one day gaze at their skies with wonder as you do at yours. The universe is always changing, always moving, and we, with our brief lives, are part of the grand change. So, when you feel alone or insignificant under the vast stars, remember, you are significant. You are the universe, as much as any galaxy, as much as any star. You are the cosmos made conscious, a fragment of the sky that knows itself. Your heartbeat echoes the first vibrations of the Big Bang. Your breath echoes the expansion of space. Your gaze into the night is the universe contemplating its own existence. From the silence before time to the symphony of the present, we have traveled together. The hydrogen that appeared in the first second now courses in your blood as part of H2O, and the light first released in that primordial fire now gently warms the space between galaxies at just a few degrees above absolute zero. The universe remembers its origins, not just in background radiation and in drifting atoms, but in you. You carry within you the memory of stars and the memory of that first, brilliant moment of creation. Our journey from nothingness to structure, from the void to the vast, has been almost 13.8 billion years long and counting, and it continues. With every second that ticks by, new stars ignite, space stretches a little more, and life, at least here on Earth, lives out its complex dance. We, together, are the product of the Big Bang, and also the chroniclers of it. The tale I've told is drawn from evidence gathered by curious minds, yours among them perhaps. And in telling it, the universe is recounting its autobiography through a human voice. Now, as I finish this story, take a moment to reflect on what it means. Feel the gravity of it. Not just the literal gravity that holds you to Earth, but the gravity of understanding. You are connected to the first light that ever shone. You carry pieces of the first stars in your body. Your existence was enabled by an unbroken chain of events tracing back to that singular creation event. In a fundamental sense, you are the Big Bang, billions of years later made flesh. You are the universe's memory, its awareness, its poetry. When you look up at the glittering sky tonight, perhaps you'll see it differently. The Milky Way, arching overhead, is not just a random scattering of stars. It's the luminous spine of the galaxy we call home, itself a product of cosmic evolution and containing stars that contributed matter to make you. The gentle glow you may see on a very dark night, a faint band of light, is partly the blended light of distant stars, and partly the faint memory of the fireball of creation, still with us. The starlight that strokes your eyes is a message across time and space, a reminder that we are all part of one story, the same story. This story, my story, our story, will continue to unfold. And we, me, the cosmos, and you, the listener, are in it together. Every day, new questions will arise, new discoveries will be made. Perhaps one day, far in the future, some of those big unanswered questions will find answers. Or maybe not, and the mystery will deepen. There will always be new wonder. But whatever happens, one thing remains true. We are inextricably one. I began in silence and mystery. Now I speak through your voice and your understanding. I began as a single point. Now I am vast beyond comprehension and filled with stars, planets, and the consciousness of innumerable beings. In you, the cosmos has found a voice to marvel at itself. Through you, the universe can appreciate the beauty of a nebula, the elegance of a mathematical law, the very story of its own birth. We are the universe, marveling at the universe. The Big Bang is not merely an event that happened approximately 13.8 billion years ago. It is an ongoing process. Its echo lives in every atom, every beam of light, every breath, every thought. It lives in me, and it lives in you. We are the continuing unfolding of that genesis. We are, in a very real way, the Big Bang become self-aware. As this narrative comes to a close, let us end where we began, in silence, filled with mystery. The silence before the beginning, and the silence within you when you truly grasp the enormity of what you've heard. In that silence, feel the connection. In that silence, feel the reverberation of the first moment, still humming in the fabric of reality. You are the universe's memory, its self-reflection, its living awe. The atoms of your body, the thoughts in your mind, they are the universe too. When you breathe, it is the cosmos breathing. When you wonder, it is the cosmos wondering about itself. And so the story of the Big Bang, of everything, concludes not with an ending, but with a profound recognition. We are not separate from the universe. We are the universe. We are the children of the primordial fire, heirs to its radiance, curators of its memory. In us, the universe remembers its fiery birth. In us, the universe gazes back at its own vastness and understands, for the first time, what it is. The journey that began in silence and mystery continues through us. We carry the story forward in our atoms, in our lives, in our quest to know and to explore. The universe began as a singular, wordless moment of creation. Now it sings through the chorus of life and intelligence that it has spawned. It remembers. Look around you, at the stars, at the ground beneath your feet, at your own hands. All of it, every bit, is part of a single, unfolding reality that started so long ago in an instant of unimaginable power. The cosmos has been on a long path, from simplicity to complexity, from chaos to structure, from unconsciousness to consciousness. And that path runs through you. The story of the Big Bang is not a tale of the past. It is alive in you and me right now. We are its latest verse. Our thoughts and feelings are its newest expressions. As long as there are beings to wonder and to seek, the universe will continue to know itself, and the memory of the beginning will never fade. In the quiet that follows now, take a breath and realize your breath is the universe inhaling and exhaling. Your life is a continuation of that first moment of Genesis. The atoms in your body will persist long after your form is dissolved, cycling through nature, perhaps eventually returning to the stars. Nothing is lost. Everything transforms. The Big Bang was the birth of time, but it was also, in a way, the birth of meaning. For without it, no eyes could see, no minds could understand. Through countless transformations, that event led to this moment, where a part of the universe can articulate its own epic. How remarkable, how beautiful that is. As I, the universe, conclude this meditation on my origins, there is one final reflection I wish to leave echoing in the stillness.
We are the universe, remembering itself.
Our very existence is the cosmos's memory made real, its mind awakened. We are the legacy of the Big Bang. In us, the universe has found a voice to tell its story, to ask its questions, and to appreciate its own splendor. In us, the universe knows itself, perhaps for the first time, but certainly not the last. The story goes on, and we will forever be a part of it. From the first silent mystery to the radiant present and into the unknown future, we journey together. You, me, us. We always have. We always will. We are the memory of the Big Bang, and through us, the universe endures. We float in the darkness between stars, a small collective of minds gazing up in wonder. We stand under the night sky, awash in starlight that left its sources millions of years ago. Above us arcs the Milky Way,
a pale river of stars flowing across the heavens. In its gentle glow, we feel both tiny and profoundly connected. We know that each pinpoint of light is a sun like our own, burning with the same kind of fire. The iron in our blood was forged in such stars long ago. The gentle silver glow of the galaxy reminds us we are made of this universe. We have always been children of the stars, built from their dust, shaped by the physical laws that govern everything we see. The cosmos is vast and old, yet it obeys the same simple truths everywhere. The same chemistry that lets us breathe traces across the spectrum of distant suns. The same gravity that pulls an apple to Earth binds the swirling arms of distant galaxies. There is an eerie harmony to it all, as if the universe knows how to stay consistent with itself. We share this cosmic stage with countless stars and at least as many questions. On a clear night, as we peer into the depths, we find order amid the chaos. Galaxies dance in clusters, bound by gravity's invisible web. Stars live and die, spreading heavy elements that will become new stars, planets, maybe life. There are fundamental numbers, the strengths of forces, the masses of particles, the speed of light, that seem precisely tuned to weave this cosmic tapestry. If the forces of nature were only slightly different, perhaps atoms could not hold together, or stars could not shine long enough for life to arise. But here we are, in a universe that lasts billions of years, with stars that furnace the elements of life, and a planet just temperate enough for us to ponder it all. It's a breathtaking balance. In the grand cosmic darkness, the laws of physics serve as a steady beacon, guiding the formation of everything from the smallest atom to the largest galaxy. Our universe appears to be a harmonious whole, governed by elegant rules that we have only begun to decipher. Under this starry dome, it's natural to feel that our universe is complete unto itself. For generations, we've used the word universe to mean all there is, the totality of existence, everything that ever was or will be. We have believed, as Carl Sagan once poetically intoned, that the cosmos is all that is, or ever was, or ever will be. Our ancestors saw the stars as eternal and unchanging lanterns in the firmament. Today we know those lights are distant suns, but we still assume the collection of them, the universe, is the ultimate container of reality. It contains us, our planet, our galaxy, and all the far-flung galaxies we observe. It's immense beyond our imagination. Hundreds of billions of galaxies, each with billions of stars, spread across space that has been expanding for nearly 14 billion years since the Big Bang. Standing in the hush of a midnight landscape, seeing the infinite stars overhead, we are tempted to think this is everything, that beyond the glittering boundary of what we can see, there is only endless darkness. And yet, a question quietly rises, like the soft glow of pre-dawn. What if this isn't all there is? What if the magnificent expanse we call our universe is only one drop in a much grander cosmic ocean? As we let our eyes drift across the sky, we cannot help but wonder. We humans have had to expand our perspective many times before. Once, we thought our Earth was the center of everything, until we learned it is one planet among many orbiting the Sun. Then we thought our Sun was unique, until we found it is one star among billions in the Milky Way. We believed our galaxy to be the entirety of creation, until other galaxies were discovered, filling the universe in every direction. Each time, we've had to surrender a bit of our cosmic self-importance and accept that the universe is bigger and more varied than we knew. Now, a new revolution in thinking may be upon us, the idea that our entire universe might not be the only universe. Perhaps it is we who are in a bubble, one realm among countless others. The word universe, meaning everything, might itself be too limited. What lies beyond everything we know? This is the startling possibility that scientists and philosophers are grappling with in the idea of the multiverse, a multitude of universes, perhaps infinitely many, existing in ways we are only beginning to theorize. It sounds like science fiction, other universes with other stars, maybe even other versions of ourselves. Yet this concept did not arise from idle daydreams. It emerged from deep puzzles in physics and cosmology. As we peer closer at the fundamentals of our universe, its origin, its laws, its quantum underpinnings, we find hints that our cosmos might be just one of a far larger collection. Why is our universe so hospitable to life? Why did it start with just the right conditions for galaxies to form? What happens at the edges of space and time, or inside a black hole? Modern science suggests answers that lead to a profound outlook. Our universe may be one node in an endless cosmic web of universes. For a moment, let's linger on that thought. If true, it would mean when we look up at the night sky, we are not just seeing all that is, but merely our own local neighborhood within an unimaginably vast ensemble. It would mean that beyond the cosmic horizon of 46 billion light-years, beyond the furthest galaxies we can ever see, space might keep going and going, potentially forever. And if space goes on forever, then logically, somewhere far beyond any hope of observation, there could be other regions of the cosmos entirely disconnected from ours, perhaps even following different scripts of reality. Could it be that the starry sky we see is like one page in an infinite book, a book with every possible page? The notion is as exhilarating as it is disorienting. Our heartbeats quicken at the bravery of asking such a question. Is our universe just one of many? We take a deep breath, steady our thoughts, and step through the looking glass into this radical idea. To explore the multiverse, we must journey back to the very beginning of our universe, to the first fraction of a second after the Big Bang. In that embryonic moment, according to our best theories, an extraordinary thing happened. The universe expanded at a stupendous rate, far faster than the speed of light, ballooning from subatomic size to astronomical size in the blink of an eye. We call this event cosmic inflation. It's a powerful idea developed in the 1980s to solve several riddles about the early universe. Why is the cosmic microwave background, the afterglow of the Big Bang, almost the same temperature everywhere we look? Why is space so flat and smooth on large scales? Inflation provides answers. A burst of exponential expansion stretched the young universe, smoothing out irregularities and flattening space, much like inflating a crumpled balloon. When we look at the sky today, the uniformity we see in the afterglow is the fingerprint of that inflationary era. The evidence for inflation has grown persuasive. Subtle patterns in the microwave background radiation and the distribution of galaxies align with what inflation predicts. It's not proven beyond all doubt, but most cosmologists have embraced inflation as a key chapter in our cosmic history. Yet inflation, in solving old mysteries, opened a door to an even grander possibility. The very equations that describe inflation imply that it may not have been a one-time event that neatly began and ended everywhere. Instead, inflation could be an ongoing process, still happening in distant regions beyond our view. The idea is called eternal inflation, and it works like this. Quantum fluctuations in the infant universe meant that different parts of space ended inflation at different times. Our entire observable universe is thought to be one pocket, one bubble, where inflation stopped and normal expansion took over, allowing matter to coalesce into galaxies and stars. But elsewhere, beyond our bubble, other regions might still be inflating or have inflated at different rates, budding off their own bubbles of space-time. In this picture, the Big Bang isn't a unique event. It's happening over and over in a vast inflating background. New universes, bubble universes, are constantly being born like foam on the crest of an endless wave. Imagine the multiverse as a great cosmic foam, with bubble universes instead of soap bubbles. Each bubble is a self-contained universe, rushing outward, separated from its siblings by regions of still inflating space that stretch faster than light, preventing the bubbles from easily colliding or interacting, though perhaps occasionally they might, like bubbles bumping in a bath. Our universe would be just one bubble in this frothy sea. Inside our bubble, we see the aftermath of our own Big Bang. We see galaxies flying apart as space expands, but our bubble has an edge beyond which we cannot see or travel. And beyond that edge, more bubbles, more Big Bangs, more universes. Inflation never completely ends. It keeps spawning new universes indefinitely, some perhaps even infinitely far away. This concept transforms the Big Bang from the beginning of everything to the beginning of our local universe, one patch amid an eternally growing mosaic. We find ourselves no longer at the center of the stage, not even the only stage. We are on one island, in an infinite cosmic archipelago. In this scenario, space itself is unimaginably vast, possibly infinite, and carved into domains, bubbles, each a cosmos in its own right. What would those other universes be like? They might be broadly similar to ours or wildly different. Some could be almost empty, inflation ending in them in such a way that few particles condense, barren voids with no galaxies. Others might be dense and violent, collapsing in on themselves or never cooling enough for stars. Crucially, the laws of physics might be different in each bubble. This isn't just speculation. It arises naturally when we combine inflation with another leading theory in physics, string theory. String theory attempts to unify all forces of nature by positing extra dimensions of space and tiny vibrating strings as fundamental ingredients. It's a bold, mathematically rich framework. One striking feature of string theory is that it doesn't predict a single unique outcome for the properties of our universe. Instead, it seems to allow a vast number of possible worlds, each corresponding to a different way the extra dimensions can be curled up or the strings can vibrate. Physicists call this huge range of possibilities the string theory landscape. Estimates suggest there could be on the order of 10 to 500 different self-consistent universes in this landscape. A number so huge, it defies comprehension. That's a 1 followed by 500 zeros, an astronomically large number of possible universes. If string theory's landscape is real, our universe is like a tiny oasis in a desert of possibilities. Why did we get this particular set of physical constants and not another? For decades, scientists hope to find a principle that picks out exactly our universe from the myriad possibilities, some fundamental reason our cosmos had to be the way it is. But so far, no such principle has been found. Instead, an idea gained traction. Maybe all those possible universes exist somewhere in the multiverse, and we find ourselves in this one because, out of the spectrum of possibilities, this is one of the rare universes where conditions allow observers like us to arise. This line of thinking is known as the anthropic principle, specifically applied to the multiverse. It says, consider that we can observe this universe. That simple fact biases what kind of universe we should expect to observe. We couldn't exist in a universe where, say, gravity was so strong that the universe collapsed in a second, or so weak that no stars formed. We couldn't marvel at the stars in a universe with no stars. So perhaps there are countless universes with varied physical constants, and naturally, we find ourselves in one of the Goldilocks universes. Not too hostile, not too sterile, but just right for life. This isn't a teleological or mystical argument. It's a kind of cosmic selection effect. Out of a multiverse of all sorts of universes, we, the observers, will only be in those universes that can support observers. It's a profound and somewhat unsettling idea. It means that many of the miraculous coincidences that make our universe habitable, the precise strength of the strong nuclear force, for example, which if slightly different would prevent stars from synthesizing carbon, or the value of the cosmological constant, the energy of empty space, which is so small that galaxies had time to form, might not be miracles at all, but simply one lucky ticket in a giant cosmic lottery. Our universe won the lottery of existence, allowing complex structures and life, but there were many, many tickets, universes, that were drawn. We naturally wake up in a universe that's a winner, because only winners get to have someone wake up and ask the question, This anthropic reasoning is controversial. Some scientists find it unsatisfying, akin to saying, "We're here because we're here." Others point out that it did make a successful prediction. Decades ago, physicist Steven Weinberg used anthropic arguments to estimate the cosmological constant's value, reasoning that if it were much larger, galaxies wouldn't form and we wouldn't be here. His estimate was on the right order of magnitude to what was later observed as dark energy. That gave some credence to the idea that perhaps our universe's properties are drawn from a random distribution of possibilities across a multiverse. So inflation gives us a picture of an ever-growing, bubble-populated multiverse, and string theory suggests each bubble could have different physics, forming a patchwork of realities. The multiverse as a cosmic quilt, each patch a universe with its own pattern. We might inhabit a patch where the forces and particles are tuned just so, while far off in another patch, the fundamentals might be shifted. Maybe that universe has heavier electrons, or a faster speed of light, or even different numbers of dimensions. It boggles the mind to consider the variety. Many of those universes would be dull or inhospitable. Just as most of space in our own universe is cold and empty, most universes might not host life. But in an infinite ensemble, even rare conditions, like the specific mix that allows life, will occur infinitely often. Infinity has a way of making even the rarest outcomes inevitable somewhere. If space is truly endless and inflation eternal, then somewhere, right now, there are fantastical worlds. A galaxy where every star is encircled by habitable planets. Or a universe where purple clouds of cosmic dust think thoughts. And also, scattered in the multiverse, would be countless worlds nearly identical to ours. In an infinite expanse, eventually the patterns of particles that make up you and me will repeat by chance. It's been estimated, in a straightforward infinite space scenario, that the nearest exact duplicate of our observable universe could be incredibly far, 10,118 meters away, a number so huge we can barely fathom it. But if space truly goes on forever, somewhere out there, that duplicate exists. And not just one, infinitely many. This isn't even invoking exotic theory. This is a consequence of simple infinity plus the finite ways particles can arrange. It's a mind-bending implication. The multiverse could contain other people who are, to all intents and purposes, you, living out every alternative history that could have befallen you. Before that notion makes us lose our grip, let's step back and approach the multiverse idea from a different angle. One that doesn't even require distant, unreachable corners of space, but might be unfolding right here and now, in tandem with our own lives. This brings us to the quantum realm, and to the many worlds interpretation of quantum mechanics. At first glance, this has nothing to do with the bubble universes of inflation. It's a separate thread, born from the mysteries of the subatomic world. Quantum physics famously tells us that particles can exist in a superposition of states. They can literally be in two or more conditions at once, like a spinning coin that is both heads and tails until we catch it. Only when we observe or measure the system does it seem to choose an outcome. For example, a single electron can pass through two slits at the same time and interfere with itself, a behavior which defies classical logic. In the traditional view, the Copenhagen interpretation, the act of measurement causes the set of possibilities to collapse to one actuality. Why or how that collapse happens is still debated. It's as if nature randomly selects one path for reality to take, out of many potential ones, at the moment of observation. In 1957, a bold young physicist named Hugh Everett III proposed a different solution. What if the wave of possibilities never actually collapses? What if instead, at each quantum event, the universe splits into branches, each branch realizing one of the possible outcomes? In one branch, the electron went through the left slit. In another, it went through the right. When you measured it, you became split as well. One version of you seeing the electron here, another version seeing it there. Each version is real, but they exist in separate, non-communicating parallel worlds. At the moment of measurement, reality's timeline forked. According to Everett's Many Worlds Interpretation, MWI, this is happening constantly, all around us, at the microscopic level, and by extension, at the macroscopic level too, since every big thing is made of quantum particles. The entire universe is continually branching into countless parallel universes.
It sounds like something out of a fantasy novel. Every decision, every chance event spawns a new world. But this idea is grounded in the same rigorous mathematics that makes quantum mechanics the most successful physical theory we have. Everett argued that if the equations say a particle can be in multiple states, maybe it truly is. And the only reason we experience a single outcome is that our consciousness follows a particular branch. Other outcomes play out as well, but we, this particular copy of us, only witness one. Another copy, another we, witnesses the other outcome, and neither version can interact or even know about the other after the split, because the whole universe's state has separated into non-interfering branches. Let's make this more concrete with a whimsical example. Suppose we flip a quantum coin, perhaps by measuring the spin of an electron, which has a 50-50 chance to be spin up or spin down, analogous to heads or tails. According to many worlds, when we check the result, the universe bifurcates. In one universe, we see the coin come up heads. In another universe, we see it as tails. In that moment, two versions of us emerge, each unaware of the other, each continuing forward, believing that our coin toss gave a definitive result. It didn't feel like a split. Each of us experienced a perfectly ordinary coin toss with a single outcome. But collectively, the deeper reality now encompasses both outcomes. Extrapolate this to every quantum event everywhere. Atoms decaying, neurons firing, photons reflecting. The rate of branching is beyond colossal. Effectively, with each fraction of time, the number of parallel universes multiplies, containing every possible way events could have unfolded. By this view, the entirety of creation is a constantly splitting tree, with trillions upon trillions of twigs sprouting each instant, each twig a full universe with a distinct history. It's an almost overpowering picture. If it's true, then right now there are unimaginably many versions of you living out other lives. Most of those versions are nearly identical to you, differing maybe only in what you had for breakfast yesterday or whether you sneezed an hour ago. Some are more divergent, versions of you who pursue different careers, live in different cities, speak different languages. For every choice you've ever wondered about, what if I had taken that other job? What if I had said yes instead of no? There is, if many worlds is correct, a universe out there where you did exactly that. Even for outcomes beyond your control. What if the storm hadn't hit? What if my favorite team won the championship? The alternatives happened in other branches. It's a multiverse not separated by distance, but by decoherence in quantum phase space. A fancy way of saying, the worlds occupy the same space, but cannot interact after they split, like ghostly layers of reality that are intangible to one another. They're here, but out of reach, each as real as the one we know. The many worlds multiverse is different in character from the cosmic bubble multiverse, but they're not mutually exclusive. In fact, if both theories are true, every bubble universe born from inflation might in turn branch into quantum many worlds, creating a kind of nested multiverse, an ever-branching fern of universes sprouting off other universes. But even on its own, the quantum branching idea profoundly changes how we see our place in reality. We might say, in a way, that the universe is remembering every fleeting possibility by giving it its own world. Nothing is forgotten or discarded. No potential outcome is truly lost. If something could happen, it does, each in its own branch. This notion of parallel worlds has seeped into popular imagination through science fiction, but here we're discussing it as a serious interpretation of physics. Many worlds has gained more acceptance among physicists in recent decades, especially as it offers a straightforward, if extravagant way to make sense of quantum puzzles without requiring a special, ad hoc rule for observers. In many worlds, there is no mysterious wave function collapse. The wave function, the mathematical description of a system's possibilities, just keeps evolving smoothly. The collapse we perceive is simply us finding ourselves on one branch. In the grand scheme, the wave function of the cosmos contains all branches at once. From a bird's eye view, there is just one quantum universe, one multiverse, evolving deterministically, encompassing every possibility. From our limited frog's eye view inside one branch, we see randomness and choice, not realizing the other outcomes also came true, just not in our world. As mind-boggling as the multiverse of many worlds is, we must acknowledge it might be unprovable in the usual sense. The alternate branches cannot be contacted. They drift out of phase permanently. Similarly, the bubble universes from eternal inflation are separated by more space than light can ever traverse, so we cannot see or travel to them. Critics of multiverse ideas often point out that if these other universes are forever unobservable, can we truly call this science? It's a fair question. Proponents argue that if a theory that we can test, like inflation, predicts a multiverse as a natural consequence, we shouldn't ignore that prediction just because it is difficult to verify directly. We might find indirect evidence or at least consistency checks. For example, while we cannot see other bubble universes directly, they might have, in rare cases, collided with our bubble in the distant past. Such a collision could leave a subtle round pattern in the cosmic microwave background, a bruise on the sky. Physicists have actually searched our sky maps for hints of such bubble collisions. So far, none has been convincingly found. If one day a circular anomaly in the microwave background were detected, consistent with another universe grazing ours long ago, it would be a groundbreaking, if indirect, confirmation that we're part of a multiverse. Similarly, with many worlds, while we can't hop between branches, experiments in quantum physics, like interference experiments with ever larger objects, continue to validate that superpositions are real. Many worlds takes those results to their ultimate conclusion. As our theories develop, we might even find more than one reason to believe in a multiverse. It's intriguing that completely independent lines of inquiry, cosmology on the largest scales, and quantum physics on the smallest, both hint at universes beyond our universe. And string theory, operating at the nexus of quantum gravity, adds its own multiversal flavor with the landscape of possibilities. These ideas paint different portraits of the multiverse, but they could be facets of one grand truth. Perhaps our reality has layers, the vast physical multiverse of regions beyond our view, sometimes categorized by physicists as Level 1 and Level 2 multiverses, with Level 1 being just an extension of our space, and Level 2 being different bubbles with different constants. The quantum multiverse of branching outcomes, Level 3 in one classification scheme, and even the ultimate abstract multiverse of all possible mathematical structures, Level 4 in that scheme. That last one, the Level 4 multiverse, is a conjecture by cosmologist Max Tegmark that every self-consistent set of laws, every mathematical structure that could describe a universe, is realized as its own universe. In such an ultimate multiverse, not only are constants different, but the very laws and fundamentals could differ. Universes with different numbers of dimensions, or entirely different particles, or physics beyond our imagining. It's a speculative idea, bordering on philosophy. In the realm of all possibility, nothing is forbidden. If such a Level 4 multiverse exists, our bubble of a universe is just one equation in the library of all equations. We mention this cosmic vision to acknowledge how far the multiverse concept can go. It's the broadest possible extension. Everything that can exist does exist in some universe. In a sense, it would answer the question, why is there something rather than nothing, by suggesting that nothing is just one option, but in the grandest multiverse,
every option is instantiated. Thus, there is something, and indeed everything. But even leaving aside that extreme level, the more grounded multiverse ideas give us plenty to ponder. Let's now gently descend from these theoretical heights and consider what it means for us if we truly live in a multiverse. How do we find meaning and identity in an existence where there may be countless duplicates of ourselves and innumerable worlds with perhaps no obvious connection to ours? It can feel overwhelming, even disorienting, to contemplate that in the cosmic grand scheme, our entire observable universe, everything we've ever seen, might be a speck, and a redundant speck at that, one of infinitely many similar specks. It raises profound questions about significance, purpose, and uniqueness. One immediate question is about identity. We normally think each of us is a singular individual with a singular history. If the multiverse is real, especially the quantum many worlds multiverse or the infinite space multiverse, then there are other yous out there. Some are extremely close to you, differing perhaps only by a single thought or atom's position. Others diverged more significantly at some juncture. Are those people you in any meaningful sense, or are they merely separate individuals who happen to share your name and genetic makeup and memories up to a point? This isn't entirely abstract. Consider an analogy. Identical twins share nearly the same DNA and often a similar upbringing, but we still regard them as two persons. Parallel selves in alternate universes might be thought of similarly. Each one is a unique person, even if at one time they were the same person. Before splitting or before diverging, conditions made them different. We might need to rethink what we mean by self. Perhaps we're not an indivisible essence, but rather a collection of potential selves, only one of which we experience directly. In one philosophical view, inspired by the multiverse, who you are could be seen as a story, a narrative thread through one sequence of events. Your other selves have different narratives. Each narrative is valid and complete in its own universe. We, in this universe, are following one particular storyline. Our other selves follow their storylines. We branch like the limbs of a tree, sharing roots and trunk, our past, then splitting into separate boughs. Is the tree as a whole us, or is each branch a different us? It might be a matter of perspective. There's a poetic notion in the multiverse context. We are like a branching tree or a splitting amoeba, continually dividing. The I that exists after a branch may not be aware of the other branches, but collectively, they all originated from the single organism that was I before. This can trigger a mini identity crisis if we take it seriously. Am I just one of many? And if so, does my life matter less or more? One could argue it becomes more precious. I am the only version of me that gets to experience this particular sequence of events. Yes, there are uncountable other versions, but their experiences are theirs, and mine are mine. I, this branch of me, will never get to see what happens in the other branches, so for all practical purposes, my reality is the one I have. In that sense, nothing changes. I still must make choices and find meaning here. Alternatively, one could derive a sense of comfort that somewhere another me makes choices I regret not making, or achieves goals I failed to achieve, or keeps alive those I lost. But equally, somewhere I may experience tragedies I've been fortunate to avoid. It's a double-edged sword. What about morality and responsibility in a multiverse? If every possible outcome happens, does that diminish our responsibility for our actions? One might think, in another universe, I did otherwise, so what does it matter what I do here? But from the standpoint of each universe, consequences are very real. If I choose to be kind in this world, someone in this world is helped. That doesn't get erased by the fact that in another world, I might have been unkind. Each branch is separate and actual. We can't excuse misdeeds by pointing to another branch where we did good. Our local moral reality is what counts for us and those around us here. However, the multiverse could make us more empathetic to the range of human or cosmic experience. For anything someone can go through, there is likely a universe in which it occurs. It's a strange kind of consolation and caution at the same time. It might also challenge religious or spiritual views. For instance, if one believes in a guiding plan or singular purpose, a multiverse complicates that. Is there a separate plan for each universe, or one plan that encompasses all? If a deity exists, perhaps the multiverse concept elevates that deity's creativity to infinite heights, creating not just one universe but a boundless array. Or conversely, some might feel the multiverse removes the need for a creator entirely, as it could explain fine-tuning without invoking design. These are deep waters where science and philosophy meet, and each of us may come to different personal conclusions about them. Let's step away from the heavy epistemology and imagine in a more playful way what the multiverse implies. It means every dream is somewhere a reality. Perhaps not literally the kind of dream you have at night, but any coherent scenario you can think of likely exists in some universe. A world where dinosaurs never went extinct and evolved intelligence. Physics doesn't forbid it, so it's probably out there in an alternate history. A planet where the continents formed a different shape, where an empire that fell in our history prospered in another timeline. The multiverse can be seen as a grand cosmic library of all possible stories. We happen to be leafing through one particularly engaging book, our life, our universe. But around us, on shelves stretching to infinity, are all other books that ever could be written. Some nearly identical to ours, some radically different genres altogether. This literary metaphor might bring a certain comfort. Our joys and sorrows, unique as they are to us, are also part of a vast tapestry of all joys and all sorrows that can ever be. We are not alone in any absolute sense. Existence in its totality contains others who have felt what we feel, done what we do, in one universe or another. In one sense, the multiverse can make us feel extraordinarily small, one tiny being, in one tiny universe, among who knows how many. But in another sense, it can make us feel profoundly connected, part of a much larger existence, threads in a boundless cosmic cloth. There is also the perspective of humility and open-mindedness that the multiverse invites. If our universe, the grandest thing we know, is just a drop in a sea, then the lesson of Copernicus continues. We are not the center, and even the reality we take for granted is not the whole show. That doesn't diminish the beauty of our world. In fact, it may enhance it. How special that, in an infinite multiverse, we have this particular universe to call home. Out of a multitude of possibilities, we get to experience this one, with its specific sky, its particular laws, its unique living earth. It's like being dealt a particular hand of cards from an infinitely large deck. The odds of getting exactly this hand were infinitesimal, yet here it is, and it's the only hand we'll play in this game. That realization can instill a renewed awe for the gift of existence. We look at the sun and think, in other universes there may be different suns or no sun at all, but here we have this golden star warming our days. How marvelous. We taste a peach or listen to a melody and realize this experience might be rare in the grand ensemble of universes. What a privilege to be among the beings who can taste and listen. As we near the end of our journey through the multiverse, we find ourselves returning to where we began, under the canopy of stars, but with our minds expanded and our hearts contemplative. What have we learned? We learned that current science, as far as it has pushed, allows reality to be far larger and more varied than what we directly see. We learned that our universe might be just one wave on an endless ocean, one bubble in a boiling cosmic pot, one branch on an ever-dividing tree of realities. We entertained the possibility that our dearest laws and constants might be parochial facts, different in another universe, that our life here is one of many lives we might be living across parallel worlds. We considered how that might reframe our sense of self and our search for meaning. Yet after all that, we have also learned
that the here and now still matters, perhaps more than ever. The multiverse idea, rather than making everything meaningless, can make everything meaningful in its own local context. Each universe is like a poem, complete in itself. The existence of other poems doesn't reduce the beauty of this one. Our narrative, the story of us in our universe, is still unique to us. We remain the authors of our choices and the caretakers of our world. If indeed the cosmos is remembering every possibility through the multiverse, then living our lives authentically is our way of contributing to that cosmic memory. We are the universe, or multiverse, experiencing itself in one of myriad forms. There's something profoundly poetic about that. It suggests a unity behind the diversity. Just as millions of cells make up one organism, perhaps countless universes all exist within one overarching reality. We might never observe those other universes, but through science and imagination, we can feel a sense of their presence. In a way, contemplating the multiverse brings us a sense of companionship in the cosmos. The vast loneliness one might feel, thinking of how empty most of space is, could be alleviated by imagining that beyond our horizon are other universes brimming with their own wonders. Some might harbor life, minds, civilizations, utterly alien or perhaps oddly familiar. We cannot know, but it's intriguing to think that creation did not stop with our world or our universe. Nature, it seems, never runs out of creativity. The multiverse would be the ultimate expression of fecundity, an infinite garden of worlds where all possibilities bloom. Now, as we let these ideas settle, we might worry, will we ever be sure the multiverse is real, or will it remain forever a tantalizing hypothesis? It's possible we may find stronger evidence, a clear sign of a universe beyond ours imprinted in subtle data, or a theoretical breakthrough that virtually demands the existence of other universes. Or we may find that our theories were mistaken or incomplete, and the grand multiverse doesn't exist as we conceived. That is the nature of science. It evolves. But whether or not the multiverse is physically true, exploring it in our minds has value. It stretches our imagination and challenges our assumptions about reality. It teaches us not to take everything for granted as truly everything. There may always be more beyond, unknown domains to discover or conceive. In the end, thinking about the multiverse is a bit like standing at the shore of an endless sea at night. We see the dark waves and hear their roar, but we cannot see across to the other side. In fact, there may be no other side. We know not what lies over the horizon of water and darkness. It could be more ocean, stretching out without limit. We suspect it is. And perhaps, out there in the cosmic ocean, there are other explorers on other shores, under other skies, wondering if anyone else is out there. In our universe, on our small planet, we've long wondered if we are alone in the cosmos. The multiverse concept extends that wonder to our universe itself. Is our universe alone or one of many? It is a profound shift of perspective, yet somehow a natural continuation of the trajectory we've been on since Copernicus. Every time we thought we were singular, we found we were part of a multitude. Why should universes be any different? Nature has shown a love for prolific abundance, countless stars, countless galaxies. Perhaps it also made countless universes. As we conclude this exploration, let's allow ourselves a moment of quiet reflection and awe. Above us, the night is still and clear. The stars shine down indifferently, as they have long before we understood any of this. We realize that even if there are infinite universes, we still only see our sky, and it is beautiful. The multiverse, if it exists, doesn't make our universe any less wondrous. In fact, it makes every glint of starlight even more poignant, knowing that it might be one of uncountable stories. And yet it is our starry sky, our chapter of the cosmic tale. We feel a sense of gratitude for being alive in this vast, enigmatic reality, whatever its true extent may be. We turn our gaze from the heavens to each other.
We, the collective voice in this narrative, represent all of us together, trying to understand existence. In confronting the idea of the multiverse, we have shared a journey of imagination grounded in science, and science elevated by imagination. It's a journey that has taken us to the borders of knowledge and beyond, into realms that test the limits of language and thought. Such a journey can be humbling. It reminds us that there is so much we don't know, but it can also be inspiring. It shows that we as humans have the capacity to envision realities far beyond our mundane experience. Perhaps someday in the distant future, our descendants will find ways to gather more evidence or even harness knowledge of the multiverse. Or maybe the multiverse will remain an eternally tantalizing concept, never fully confirmed. Either way, it changes us in the here and now. It expands our conception of what reality could be. It invites us to partake in a cosmic perspective that is at once deeply intellectual and deeply spiritual, acknowledging the possibility of infinity and the mystery that comes with it. So, what if this isn't all there is? Then our stars and galaxies are just one refrain in an endless cosmic song. Does that make them any less melodious? No. To us, they are everything, and they are precious. And if in addition, the choir of creation is larger and more complex than we knew, then there is even more reason to be filled with reverence and wonder. We close our eyes and imagine for a moment, countless universes shining like bubbles in a vast foam, or like an orchard of worlds stretching out beyond sight. We imagine each universe has its own sky, perhaps its own version of someone looking up and feeling small yet curious. In this grand symphony, we, in our universe, contribute our part. A small, clear voice in an unspeakably large choir. The song is one of existence, exploring all possibilities, and through science and storytelling, the cosmos, or multiverse, finds a way to know itself through our eyes and our understanding. Now we open our eyes again to the familiar stars above. They seem a little kinder now, as if winking at a secret we've shared. The night breeze is cool, carrying the earthy scent of our world, our dear world that nurtured us. For all this talk of other universes, it is here that we love and strive and wonder. Here is where we make our meaning. The multiverse has not answered the question of meaning for us. Instead, it has enriched the context in which we ask it. Meaning, it seems, is ours to create, in whatever corner of the multiverse we inhabit. We stand together under the cosmos, humbled by its vastness, yet uplifted by its possibilities. We feel small, but not insignificant, transient, but not pointless. We are part of something so much larger, and that realization does not diminish us. It ennobles us. It means the adventure of discovery will always continue. There will always be new horizons to explore, new questions to ask. Our universe was once unknown and mysterious, and we have made it familiar. If there are other universes, perhaps one day, in some form, they too will become part of the purview of understanding. Until then, we carry the torch of curiosity forward, illuminating what we can and respecting the darkness of what we cannot yet see. In the multiverse of ideas, we have voyaged through reflections and dreams, through mirrors and branching streams of time. It's time now to gently return to our own world. We take one last, long look at the stars. The night is deep and silent. In that silence, there is a whisper of infinity. We sense the multiverse not as an abstruse theory, but almost as a presence, a silent chorus behind the curtain of reality, singing possibilities. And we, tiny though we are, sing along by simply living our lives and seeking truth. When dawn comes and the stars fade, we will go about our day, but perhaps with a renewed sense of wonder. Maybe we'll pause and think, the light of this morning sun could be rare in the multiverse. Let me feel its warmth with gratitude. The loved ones I speak to, the act of kindness I can do. In this universe at least, these matter immensely. The multiverse, if it exists, is not an escape from our reality, but a profound backdrop that can make our reality even more meaningful. As the first hint of morning glows at the horizon, we conclude our journey. We went seeking the multiverse and found that, whether or not it's truly out there, it has already expanded our minds. We end not with an answer, but with a feeling, the feeling of awe. Awe at the richness of the cosmos, awe at human ingenuity to even conceive of the multiverse, and awe at our own capacity to find meaning and connection in a possibly infinite expanse. Our story, the story of one universe awakening to the potential of many, becomes a kind of cosmic meditation. We step forward into the daylight, carrying this perspective with us quietly. The question, what if this isn't all there is, will continue to echo, inviting further exploration. And whenever we need to rekindle our sense of wonder, we know we can look up at the night sky, remember the grand vision of the multiverse, and feel that childlike spark again. In the face of eternity and infinity, we find not despair, but endless possibility. Our journey through the multiverse has been like traversing a hall of mirrors, each mirror reflecting a different face of reality. Now, back in our own mirror, our own universe, we smile, a small, knowing smile, because we glimpsed the hypothetical reflections and returned wiser. We carry within us the stories of myriad universes, and that makes the story of our universe all the more precious. In that spirit of appreciation and wonder, we conclude our exploration. The multiverse, real or not, has given us a gift, the gift of cosmic perspective. With it, we walk gently through our world, eyes open to the stars, hearts open to the unknown, and minds ready to embrace whatever truths the cosmos has yet to reveal. We are humbled, we are inspired, and above all, we are connected to each other, to our universe, and maybe, just maybe, to all universes.